Live on both. Let's see. Maybe. Let's turn you down just a touch. Hello, hello. I'm going to assume we're live. Let's just check. On Twitch, we are live. On YouTube, are we live? That is the next question. So we are doing both today. Yes, we are. Okay, so let me just share this. Ah, fantastic. Actually, it shared everything that I needed. Okay, let me just get up the chat for you guys. And share this with our community so I can ping everyone. Hope you're all having a great day. The particle grind continues. So, right, let's see the chat, the chatteroonies. So looks like hey, arrogant. How you doing, dude? What's up? What's up? Thank you for joining us. Just bring up the YouTube chat. So that's the Twitch chat open on my other computer. And we just need the other one, which is our YouTube chat. Alright, cool. Almost done. Yeah, so we're on the particle. How you doing, dude? Hope you're having a great day. Right, yo. Gary from the server. Thank you for joining us over on Twitch. I hope you are having a great day. Alright, so YouTube chat is up. We have Twitch chat open. Alright, I have them on my other monitor, so I can read both. Just assume this is the right one. I think it is, yes. Okay, so unfortunately the same thumbnail has appeared, but hello. Right. Alright, we're just going to grind it today. I feel like I'm making no progress on this, so we're just going to go for hours today. Yeah, I'm pretty doing great. Programming my OpenCV. Ah, right, I haven't heard of an OpenCV guy. So it's great to have you here, dude. Hopefully that's going well. Let's close this. Go away, thank you. Let's bring up our note-taking app. So I'm just going to do a bit of revision. So hopefully I'm a good, person to work alongside as you tackle OpenCV. Yes, I'll just ping everyone. I'll just let everyone know in the general that Twitch and YouTube today. I feel join whichever chat you feel more comfortable with. Either one's fine. That's just for other people. So if anyone's just chilling. All right. So how do I study? What does that mean? Let's just stop this for a minute because I haven't actually done anything yet. I'm just going to read some of my notes. Feel free to ask questions about what we're doing. I'm going to just be on the particle grind. There's no way out of this outside of just working harder, so we're just going to fucking grind it out, bros. We got the music playing in the background. The same old playlist, but I like this playlist a lot, so that's fine by me. Yes, and I'll just read this out loud. We read this like 50 times. That's exactly why we need to keep reading it. And I've also added extra notes, so we're just going to keep going through this. I'm gonna do more than just this today, revision wise. So I usually do revision, followed by revision. Then we do coding, and then we'll whatever, we read this 50 times. No worries. All right. Anyway, particle system has changed since 2010. Mostly only renders a couple of hundred particles, except with the exception of rain, which runs on the GPU. Most particle systems aren't GPU based, which reduces performance. If you have a GPU based approach, you can do things like 1 million particles. So this introduces compute shaders approach that limits the amount of interactions with other shaders to avoid moving things through memory. Hello. Thank you for joining us. It seems like you guys like Twitch, which is great. I'm glad you guys are enjoying us over here. Suggestions suggested. Hi. So yeah, I hope you're having a great day as well. You could instead use an instant rendering. In fact, not that it matters too much, but can I just yes, can I just edit this live real quick? Just want to change the thumbnail. I feel like yeah, so I'm gonna change this to, I actually have not made another, no, whatever. I actually have not made another thumbnail. Never mind. Anyway, what we could do instead is use an instance rendering and update the instance buffer in the compute shader. Yep, this is what we did. Assume that we get buffers correctly synced with memory barriers. Alex collides with the depth buffer. Okay, so this is someone in chat. I had to kind of add a note to myself here. All right. So Alex, someone from the chat, collides with the depth buffer and renders them after an update. Yeah, I think we could probably end up doing that at some point today or tomorrow. This allows us to do things like change instances to different UVs and get a nice splash effect. Yeah, okay. When a collision detection is found, I think we know. Yeah, basically we just need to get the depth texture up, and then we can do some like maths on that. I believe this is because we are using the depth buffer here. And just colliding with whatever hits, exactly what we're doing. Multi-indirect draw calls, can pull. Yes, okay. So the visible buffer. This book references a visible buffer which calls triangles from the geometry. Yeah, the YouTube chat is empty. Triangles from geometry. If there is no triangles left in the draw call, well, at least I can see everyone. To call, it does things in two phases. One translucent materials and one opaque materials. It builds a buffer with 1 bit, working with triangles. If an alpha masked is an 8 bits for storing the draw call ID, and a 23 bits store the triangle ID relative to the draw ID. Hello, Botrod Gaming on the YouTube chat. How you doing, dude? I believe this is our this is a poor man's mesh shading approach to calling triangles from geometry, meaning that I don't need to think about this. Don't need to think. You need to. I don't think I need to do this with the GPU-driven rendering particle system. I mean, we could move to mesh shading, but I think that'll be overkill. Okay, so data management. You can define a particle system as a collection of particle sets. A particle set is a... So, this book calls particle sets, you know, people call these emitters. So, a particle set is just an emitter, right? Just for anyone who's interested. A particle set is just a set of particles that shares the same priorities like textures, size, max speed, AR behavior. Each particle within a particle set keeps track of the position, age, velocity, and multiple particle sets can achieve even more complex effects. So this is all packed data, but yeah, generally speaking, that we actually generate these on the GPU rather than having a buffer. But generally speaking, you know, this is pretty straightforward. Size, position, particles per second, which is how many things get generated per second. Which right now we just generate as many as we can, which may not be the best idea actually in our engine. I should get that up open actually. Let's go on here. Oh, this song is sick. Let's give this a run, see where we're up to actually, before we continue. Okay, so we have Yeah, we fixed the random numberness of things. It is funny how small these things are relative to a rock. Now the rock is really close. But I want to scale these up, perhaps. But we have 2 particle emitters, and we're just generating them as fast as we can. Each instance, I don't know how the GPU is handling this. You know, I don't know if it's enjoying it. It's for each what is it called? For each particle, we have one instantiation of a compute shader. So weirdly, we do get some effects. Hang on, let me zoom out real quick, like almost straight away. You can see like there's some kind of lag that like causes the compute shaders to not immediately get going, which is kind of strange. Hi Garib. Sorry, but I really don't know what you're working on. Would you please give me a short summary? Of course. Thank you for asking that question. It's a great question. So I am working on a 3D game engine. The link in the source code is in the description, which I can get open. I'll just show you what it looks like. So it's on GitHub. If we go to my GitHub, it's called Void. It's the Void game engine. And yeah, the idea is that we're trying to make a 3D game engine for a 3D game that we're trying to make, right? So we have a couple of things already. I'll just fly around the scene and I'll kind of demonstrate what we're doing. So we have a 2D renderer. This is a terrible UI deliberately. The sneaky idea here is that you are able to spot immediately that this is not finished, right? This is not done. This is just a, you know, text here, replace later. So we have a 2D renderer as well. Obviously, you need that in a 3D video game. Then we go to starts, and we have this like little space game, right? So what you're seeing here is some particle emitters, but I'll leave them because I was just talking about them before. If I turn off the debug geometry, you'll kind of see what we're seeing. So this is debug geometry, so we can see where the actual collision geometry is. I've got the no clip camera at the moment. So we will just go through things, but if I were to pilot the player, which is this duck currently, this white duck, it won't go through rocks, right? So it's like a little space game that we're working on. We have some basic lighting. We have a nice directional light, which I think looks okay in space. And we have a spotlight, so if you were to fly in, you know, a really dark direction, you would be able to see a rock that's going, you know, you're about to fly into. The idea here, anyway, is eventually that we're going to have like a little gameplay, nothing crazy. We're going to be like shooting rocks and stuff like that. It's not meant to be a game that takes forever, but it's taking a lot longer than I would like. I'm trying to make the graphics look nice, because that's the only thing I really have like major control over, along with gameplay. What I mean by graphics look nice, I'm trying to work on the particles, right? I'm trying to work on the lighting. I'm trying to make like I made sure that I was very careful when I wrote the lighting model. I've recently fixed it. It actually was broken for a while. So yeah, I'm trying to make it look pretty. So you know, at least looks attractive for other people who want to play it. I am aware that you could probably make this in Unity or whatever, but you know, the idea is I'm trying to make a game with a game engine, right? That I made myself, which is hard to do. That's the goal here. A lot of this is just because I want to do it and because I enjoy doing it. And thirdly, I don't really know how to make a game outside of coding things in C++ and Vulkan. So yeah, there we go. Hopefully that makes a bit more sense, Garib. Feel free to ask any more questions about what I've missed out here. What I'm trying to work on specifically today is I want to have nice particle effects that kind of look like, eventually anyway, this is the goal. If we bring up this buck that we've been kind of messing with, and you'll see kind of like what I'm trying to aim for here. And we'll see like a picture of like this, like these fog effects, for example, are like kind of cool. And I think it would like really add to the scene if I just had like transparently sorted particles that fill up a scene with different colors, right? So that's what I'm trying to work on at the moment. We do have particles, but we don't really have any way to use them outside of just changing their position. And there's a lot of things I need to do. So if I just rerun the, because I've lost where they are. So I don't know how familiar you are with games, right? Hello, hello, on the YouTube chat. But particles are just tiny little things that, you know, particle effects. They're kind of like, they're not real particles, not like physics or anything. We have like these green effects. They're just sprites that always face the camera. It's actually kind of like a good little cheat. But as you can see, if we get really close, sorry about the bitrate here, but you can see that they're not blending together. You have like sphere, like they're not sorted. There's like there's a couple of things that just aren't, we're not quite ready yet to do like nice particle effects that we can see like in here, for example. Obviously we wouldn't use this yellow and blue, right? But that's just a demo. So yeah, that's what we're doing. Today we're trying to grind through as much maths and engineering stuff that we can do. Looking good. Thank you in the YouTube chat. Thank you, Proven Object, in the YouTube chat. I'm really not familiar with anything related to game development, but love to know how anything about it. Oh, thank you for asking questions then. Yeah, so it's if I could. No, these are all moving, so it's kind of hard to see. But yeah, these are all like little sprites that are always facing the camera, which is kind of like a cool trick. You can see it. I think you can see it most clearly if I get up an imposter game development. Hopefully that comes up with a picture or something that's kind of remotely useful because it's kind of hard to demonstrate. Right. What was I going? What do I expect? Sometimes I get caught up in game development and I forget. I forget that. Yes. Among Us exists, so you can see like, yes, we have like a real object here and like a fake image here. That's basically what we've got at the moment. We've got like just a 2D image that's faking a 3D, right? Yeah, I completely forgot. I honestly completely forgot about bloody Among Us. There we go. Yeah, too caught up in my own graphics programming stuff. So yeah, that's the cheat here, which allows us to render a lot of things all at once. And how we're trying to do this, we're trying to do this in a modern approach. So, a modern approach to particles, which is kind of tricky because you have to use something called compute shaders, which are just generic shaders that sprites are the enemy characters in the original Doom. Yes, that's a good way of putting it. Yes, sprites, you can think of like the original Doom, kind of like that. That's like an imposter, right? Yeah, Rock 11, the Rock 211. Thank you for that demonstration. Yes. So yeah, we're trying to do this in the compute shaders. So this allows us to do, this is a program that runs on the GPU. And this GPU program can do generic compute. And generic compute can be anything, right? And what we're doing right now is this simulation, this very basic simulation. Just a bit of like linear acceleration with velocity, right? It's not really complicated. We just times it by delta. And we just have like randomness, which, you know, that's why it kind of looks the way it is. So that gives us some problems, unfortunately, because this is all on the GPU, and we want to keep it on the GPU. That's faster. We lose a bit of flexibility with that because it's all on the GPU, and we want to do stuff basic, you know, like on the CPU, like maybe a bullet or something, for example. It's kind of difficult to kind of like, all right, how do we pull the data off the GPU in a way that doesn't disrupt everything? So we can do collision detection. Or is that bad at all? I don't know. Maybe we should have a CPU-based particle system to do bullets and a GPU-based one for effects. I don't know yet. So this is what we're doing. Yeah. I think I'm gonna stay here on YouTube. Yeah, no problem, Ratchet. Whatever's comfortable. I want to give you guys the options of whatever we're doing. So yes, if you want to, if people want to stay in the YouTube chat, feel free. I will look at both Twitch and YouTube chat. This is my second day on Twitch, so I'm a bit of a Twitch noob. I don't really know what I'm doing, but yeah, today I'm just going to do a bit of revision on what we've been studying up to now, so I can get better at particles. Right, so that's what we're after. Trying to rock it. Yeah, and just feel free to ask any questions about anything in particular, and I'll try my best to explain stuff for anyone who's new. Okay, cool. So we have position of the particles. Spawns per second. We have color. This is all kind of like standard like emitter / particle set stuff that we're kind of familiar with. I'm not going to do anything with this bit field. This is a way to select particles based on, you know, some uint value that we're going to have like a separate buffer for. But I'm not going to do that because it's kind of really complicated. And I think if we just set things up in the simplest way possible, we're gonna have a better chance for success, right? So, anyway, so I'm just gonna keep reading my old notes. So this is an app called Obsidian. People who have been with me on YouTube are very familiar with this. But yeah, I'm gonna code right alongside you, just like a coding buddy. I love that. I do the same thing. Yeah. Thank you for joining us, and I'm glad I can be your little co-worker today. Good luck on your projects, dude. Yeah, I literally do the same thing, so I completely understand. All particles are stored in the same buffer. Yeah, also use Obsidian, hell yeah. In the same buffer. So we have different buffers that store 32-bit fields, which keep track of whether a thing, like a particle, like if a particle emits light, and what particle set it belongs to. Yeah, so this is the thing I don't want to do. I'm gonna keep it quite simple. This is an optimization that allows us to not access the whole particle data. For example, if we have a light clustering shader, it can detect if a particle is dead by looking at a bit field without unpacking the entire particle which it belongs to. We need to make sure that our bit field buffer and our particles are one-to-one, meaning that if we access the bit field's ith element, that should correspond to the same index. I feel like I need to... yeah, do you mind guys if I take 5 minutes, not 5 minutes, but yeah, just throw in my YouTube on the Twitch side of things, if I know how to do that. Yeah, just bear with. I know this is a bit of a faff, and we've done this yesterday, but how do I? Oh yeah, I need to go to channel and then manage broadcast, I think. Or whatever it is, create a dashboard, and then manage broadcast, and then we're back here again. I need the. How did I do this yesterday? Nope. I really don't know what I'm doing. As you can see, this is my I'll forget it. You know what? Yeah, if people are interested in my YouTube, I'll just post it in the chat. Who cares? I don't want to spend all day like faffing around like we did yesterday. Hello, boys, Owen. Thank you for joining us. It's just a cache line. Yeah, it's trying to reduce bandwidth, rock to 11. That's what we're doing. So we're trying to with this unpacking and packing thing, we have this idea of trying to reduce the bandwidth. That's what yeah, thank you for joining us, by the way. It's on Twitch. For both particles and bit fields are divided into 3 main sections. One section contains the particle emit lights and cast shadows. Section 2 contains particles that only emit light. And section 3 is for everything else. We divide these 3 sections into a visibility / active, visible and active / active, and one for inactive / invisible particles. Now we do something like this, but I haven't quite worked out the kinks yet. We have an additional buffer that stores the bounds of each section in the small read-write buffer. That computes Follow you from YouTube usually, but I prefer Twitch or streaming. Glad you're here. Ah, thank you very much. Well, there we go. I'm glad you made it. Does it mean packing a struct, which thus means data non-aligned? Strange terminology. I missed something. Okay. No, it's I can actually just show you my notes further down. What it is literally we pack floats into fixed point notation, and then we store that in. Now, I don't know if you're familiar with GLSL syntax, but I'll assume you're not just for this. A UVec2 is a uint vector2, right? So it's actually an unsigned integer. So we put it in fixed point mode. So we take like this, we shove it into our vec2, and then we have to decompress it afterwards, right? So it's like a compression decompression, and that's to help with memory bandwidth. That's what it's not to do with alignment, so the CPU and the GPU sync up, although that is probably a consideration that they did come into contact with here. But this is actually fine. As you know, a uint is 4, so as long as it's 16 byte aligned, which this is, because this is just 8 times 8, which is two uints together, which would be 16, and that's fine. Not sure about this. I haven't actually added everything up, but it's not too difficult to pad things out, and I think it's fairly well distributed, all the values, to be honest. And again, the reason you'd want to do this is to reduce memory bandwidth, which is just something that Ratchet taught me yesterday, actually. So credit to him in the chat, in the YouTube chat. All right. Why fixed points? You don't want an FPU floating point processor. No, it's again, it's mostly because let's just pretend we have 2 million of these guys. Can you imagine how difficult that would be to store? A velocity of 4 vec, 3 vec and a 3 vec, plus a uint. The problem is we don't run out of memory here with that size. It increases the memory bandwidth. Some data can be quantized into smaller representations for storage. Exactly, that's exactly it. So it just allows us to. It's basically it's quantization more than compression, I guess would be the right word. And that's all we're doing here. We're just quantizing it back into floating points. If we're actually going to do the maths on the actual, the regular maths that I don't know, we do here, we're just doing the simplest maths here, right? We're just simple integration. We just add the velocity times by time to the old position equals new position. We do this in full float format, but now if we want to store it, assuming that we're using this system here, we would then pack the data back down into a smaller fixed point thing. I think I'm not entirely sure, but that's I think what's happening. I could be a little bit wrong there. Yeah, memory is generally very slow. It can be better to do maths if it means you read less memory. Yeah, exactly. So sometimes the maths is more beneficial, which you're probably familiar with, Rock 211. Sure, I do that with packing payload info into 8 bytes. Yeah, that makes sense. Yep. Which has the offsets of 3 lower bits, always a 0. I use them for status, for payloads, and use them shifting. Yes, exactly. So it's exactly the same stuff. And Boy Zoen has said, I was learning OpenGL. I took a break, and I want to watch some more experiment. Yeah. Experiment, learn how to do it. Yeah. Cool. I'm using Vulkan, but yes, you can definitely learn a lot of yeah. Feel free to ask stuff. I don't mind answering questions about stuff. It actually helps. So even if you think oh, this is I've just started learning OpenGL and I don't know what this means. It helps me we're doing a lot of revision right now, so going over old information is exactly what I need to do. So if you are learning, feel free to ask questions or whatever. Let's go. Just check our music's good. Yep, heart, gold, and soul, silver, baby. All right. For both particle buffers and bit field buffers are divided into 3 main sections. Okay, so we've done that already. This is a very the boundary buffer is a very DoD thing. Yeah, so effectively this allows us to move. I do this because I want to do data-oriented design when it comes to our buffer stuff. Obviously, we're storing in this active and inactive state divided by 3. I'm just going to stick with standard for now. We're trying to make it as simple as possible, but yes, we're going to have this inactive and active state, so we can we can store this is alive out of bounds of an array, right? Which is super useful. Information theory. This is the same amount of data if it's stored out of bounds anyway. But it allows for nicer memory. So we have three buffers, bit field. So yeah, bit field buffer. We have the boundary / active buffer and the particle buffers themselves. All tracking states. Yep, depending on what you want. Oh, cool. My main question is: I heard Vulkan is pretty different than OpenGL in that way. In that way that you can only write shaders. You can only write shader. Does buffers allow... Buffers actually, yeah. Funnily enough, that's actually one of the things that's pretty close. Like the buffers themselves, you still have SSBOs, you still have UBOs, uniform buffer objects, shader storage buffer objects. The way you access them, though, is very different. So it's the access patterns that are very different between OpenGL and Vulkan, not the actual buffers themselves. You know, because a buffer, at the end of the day, is literally just a bunch of data that sits in a thing, and the way it gets pushed to the GPU and how you access that is the actual, you know, what OpenGL and Vulkan are doing, right? So when you actually access it in the shader, it's still GLSL, you know, you can still do GLSL stuff. So that effectively is it's the same, but how you access is very different. And because I know you have, I'm a bit rusty with I'm very rusty with OpenGL, I should say. But you have uniforms, right, that you push with a name, whereas like that's not really a thing in Vulkan. Actually, there's no such thing as Ratchet in the other chat has said. Actually, there's no such thing as an SSBO or UBO. It's just the way you access it. The same buffers can be used for both. Exactly, yeah, that's true. I was kind of more suggesting that the in the shader, those buffers still exist in both OpenGL and Vulkan. So technically, yes. Buffers that you would typically want for, I should specify that sometimes you want a buffer that's accessed in a way with a uniform buffer object type pattern, then that can exist in both OpenGL and Vulkan. That's what I was trying to get at, really. And same with shader storage buffer objects. Again, that's just shader storage buffer objects are, you know, used in one way in OpenGL. Well, you can use them; they still exist. That's really because OpenGL and Vulkan are both use HLSL for shader GLSL. Yes, yeah, exactly. That's more what I was asking. Yeah, sorry, suggesting. But yeah, how you access them is very different, and that's where the difficulty kind of comes about. Yeah, we're back to YouTube. Yeah, I'm on both actually. So, are you into robotics? I'm into robotics, and you know embedded systems. I actually don't know embedded systems, but I'm concerned with memory access, right? So I do try to write things quickly. So I'm sure that you're very familiar with like how slow memory is and all that kind of stuff. I'm very keen on that. I don't think I'm very good at it, but you know, with limited hardware, you definitely have constraints that I think a lot of people take for granted. And with a real-time system, we almost have the same constraints. We just have to, instead of fit to a particular piece of hardware, right, we have to run as fast as possible. So, you know, we're very aware. I think we're probably on the same wavelength when it comes to like caching and, you know, cache hierarchies and stuff like that that we need to worry about. Yeah, dual streaming indeed. Thanks for joining us, Shadow, in the YouTube chat. Anyway, the book wants to reduce how many reads and shaders has to do as much as possible. So it applies aggressive data packing techniques. Packing mostly applies to the particles and the particle sets and 32-bit precision data that can be used to unpack a given particle. Save in HLSL, a buffer can be accessed as a standard buffer in one place and a constant buffer in another. Yeah. HLSL has a lot. HLSL has a lot of random stupid buffer types, says Ratchet in the YouTube chat. Hello, Low-Key. Thank you for joining us. Lovely to see you here. Hope you're having a great day. The particle set, I was just doing a bit of revision right now. The particle set are not stored anywhere, but is returned in a get particle function. Every time it's called, I think we're definitely going to do this, but we're going to stick with a buffer that's CPU based for now. So it's not an intensive operation. It mostly consists of assignments. I feel like I got too many things here. Anyway. Yep. Okay. Whoops. This assumes that particle structs. Yeah. Okay. So this is just an example here of us setting up some data that we pass from one struct to another, based on an index, which I assume we pass in and gets deconstructed. Yeah. It's from the particles bit field thing. Interestingly, you cannot represent a GLSL SSBO in HLSL. So Loki has said, what's a C++ project you'd recommend for a complete beginner? I highly recommend, if you go to, this is what I would do personally. Projects are fantastic. It's a great question, by the way. One Lone Coder. I go to One Lone Coder, type that in on YouTube, go to his YouTube channel, and then go to videos, and then sort by oldest. And go through these and see if you're interested in a simple, and try and pick something simple. Like, this is a fantastic beginner project where you just follow his thing and you kind of like work on that. Tetris, try and make Tetris in the console. And just scroll through and see, okay, yeah, it'd be cool to make a command prompt console game engine, which has this kind of like cool thing. Maybe you want to make this thing. Maybe you want to make this retro arcade thing. You know, all these earlier videos by this guy are very beginner friendly and awesome projects. They do get more complicated as they go on, as you can probably imagine. Like, this is getting a little harder, but honestly, it's one of the earlier stuff is like Snake. This is a great one I did. Highly recommend that. So yeah, One Lone Coder, and then, you know, pick one of the older ones that takes your fancy when it comes to coding, and hopefully that's an enjoyable project for you to do. Oops, I haven't started this, so yeah. Alright, okay, so when unpacking, this consists of normalizing values between 0 and 1, the range having minimum precision. The current age of the particles is divided by its particle set initial age and the particle velocity and age. All particle positions are relative to the particle set. Before normalizing the position of the particles, we divide by the size of the particle set. Okay, so, yeah. Right, fantastic. Okay, we want to take a particle and got some bounds. To do this, we want to scale, okay, the particle. So you can't represent all GLSL SSBOs in HLSL. Yeah, thanks for the tip. No problem, dude. Good luck with your project. So yeah, for Twitch, I've got YouTube chat open. Hopefully that's chill beans, and I'm reading some stuff. So Shadow Dev has actually done some of the things I've recommended. So, you know, you can follow his advice as well. I'm sure he's more up to date. So Rock has said, I wrote a library called Zorro, which analyzed the CPU system topology, then adjusts the threads, workloads, chunks based on the cache associativity, and shared L2s to create an optimal affinity pair run on Apple hardware. They don't allow such things. Okay, so I wrote a small function that runs each core against another core, trying to force contention, and it actually works to find out which cores share L2 cache. I see. All right, so that's good. Anyways. When packing age and velocity using UVec to these things, it's converted to a float 16T packed, into two unsigned integers, resulting in 8 bits. If you keep all the particles within the range of 0 to 1, you have a greater precision because the mantissa is small. This allows for floating points. I feel like I've got that wrong. I don't think it's a mantissa, is it? What is the... What are the parts of the floating points? Yeah, the significant figures. What? I'm just looking for... Yeah, okay. So this is probably going to be better. Yeah, the exponent. Yeah, the exponent is the... yeah, because the exponent's small, not the mantissa. Yeah, that's it's great stuff, honestly, Shadow, that you're doing. Yeah, everyone just yeah, you know, find your own path. I think it's the exponent wherever. Yeah, so where is the... Yeah, so I've got that slightly wrong, so there. Yeah, I had a feeling I got that backwards. So the exponent is very small, so the mantissa can be... It's actually the other way around. This allows for floating point numbers to be this. Doing this allows for 30-bit precision that can be packed into 3 floats in a range of 0 to 1. You can only get speeds of that, and same for velocity, but it's not squared. This would leave us with 16 bits of extra precision to store data particles. Since we do not need the extra bits, we can pack the precision into 3 fixed points of values. Sorry, each 1 bit for the sign. 20 of the fractional part. This allows for the maximum epsilon around... oh, let me fix that. Oh, that's fraction. Okay. There we go. Hi, not a Dr. Pirate. I just created a big CMates project, and now I'm starting. And now I'm staring at my screen, trying to figure out what to do. Yeah, that's kind of a tough one. Did you have to pay anything for multi-streaming? No, because I switched to OBS. So some of the alerts on is I won't see the alerts like we used to on the YouTube side. So we used to have like a big alert that comes on the screen until I figure out how to do that again. But no, because if I went to Streamlabs, that you do have to pay for that. You need to be careful with particle sets if it's too big and normalization causes aliasing or loss of precision. It can be split into multiple sets with the same settings. This can allow for particle sets. This can allow for particle sets to be called. To be. All right. That's some Spice Obsidian. Yeah, my Obsidian is basic. I don't want to make it too gimmicky, I have to admit. All you need, you need to be careful with the particle sets. If it's too big and normalization causes aliasing or loss of precision, it can be split into multiple sets with the same settings. This can allow for particle sets to be called more easily. Fantastic. Here's the packing. S, not culling. We are not culling anything. Anyway, so I think I might try to do this as well for my next stream. Yeah, good luck with your streaming, dude. So the workflow, this book has been worked out that the memory bandwidth is the biggest bottleneck for modern rendering approaches with particles. That's why we pack data. The simplest way to reduce bandwidth is to process things in one run. Yep. The particle system goes through 3 different steps, which I haven't finished. The prep phase only accesses particle sets. It produces data. Produces the data that needs to be sorted. That needs to sort the particles by visibility and compute the bounds of each section of the buffer. All right. Ratchet has said, culling is mid. Real programmers just push more geometry for fun. Yeah. Why optimize when you can just tell your user to upgrade their hardware? The Giga Chad way of optimization. My game must run on a 5090 and nothing less to keep it pure. Anyway, the simulation phase. This step is to do with initial particles, kill or respawn, sort each section of the buffer, performs part of the light culling rasterization, rasterizes small particles. Yes, we might end up having to do that one day. Yeah, let's change this song real quick. Yeah, expand is sick. Let's go with that. Okay, yeah, that is a thing. Okay. What's my computer doing? Enable now light, yeah. And rasterize small particles and update Particle velocity, age, and position. So not Dr. Pirate has said, do you use LLMs? No. I don't think I've ever used them. I just enjoy programming too much, so that's pretty much that. I have nothing against other people doing their own thing, no. I'm trying to personally, part of this is to try and get as good as a programmer as I can. And I think LLMs take that away from you. It takes away the practice and the struggle. Yes, they are quads. Yes, Ratchet, they are at the moment. But we might end up rasterizing literal pixels in a software rasterizer, but we'll see if that's even doable. So what I'm going to look up actually right now is the next thing I want to do is the depth buffer thing. I don't know if this is even relevant for what we need, but I feel like at the very least we can look at how to do a spray effect when it comes to particles. So your document title says Gen GPU 3. If oh no, that's the book name, Rock 211. So particle compute shakes. So I saw this fantastic article which we're going to try and find again. No. So that there is rasterizing. I guarantee it. That is rasterizing pixel size particles, which is a technique. Particle compute shader. Are you using point sprites for particles? Yes. Is it required that any person who wants to get into game dev must take linear algebra first? Not that one. It depends on your goals when it comes to game development. If it's 3D game development, I think maths is going to massively help you no matter what you do, and I think it's a really good idea to get into maths at some point, linear algebra being the most important. But if you're just trying to do like a 2D game engine, it's not as useful, although it's still very, very useful. No, that's a lie. Okay, it's extremely useful in both cases, but the maths that you have to do in 3D is more demanding. Yeah. Don't know about, yeah. Yeah, exactly, Gary. That's exactly how I feel about LLMs. But I feel like people can get caught up with maths and get too into it. I wouldn't say it's... So we're just going to learn how to do this. Because I want to know this thing. Oh, what am I doing? I need to make it like this, and then paste this in. So now we're going to do a bit of studying because I want to just, we need to grind this out. Yeah, so make sure you're like good enough at programming as well. That's a big thing that a lot of people get into game development a bit too early, in my opinion. Like, make sure you're good at your language. I say this all the time, but yeah, make sure you're good at your language. So I'm going to read this out loud. So I guess we can look at this, but I hope this music doesn't play. So, yeah, very nice particle effects here. I think there's a bit of bloom going on. I don't know. What is this? This is the demonstration of an explanation of particle systems designed for a tool for designers and procedural artists to create captivating effects for our game project. While this primary goal was to develop this tool, a significant focus was placed on becoming comfortable with compute shaders and techniques suitable for this task, with compute shaders playing an increasingly important role of loading CPU computation, enabling effects at a scale that would be impractical for traditional CPU processing, and befriending them. Yeah, okay. Cool. So implementation, I don't think we're going to find much information apart from right at the end. Shader loading and buffer creation, start by loading our pre-compiled shader objects. Okay. Let me just fix something real quick on my other computer. Let's get that open again. Okay, cool. So yeah, feel free to disagree with me sometimes. Maybe you should study maths before you even start, but I think it sometimes can kill people's motivation when it comes to stuff. Yeah, I typically just yap on stream. That's my breaking. All PWD. So generally, I just go until I get tired. And Grebe has said, let's just read this real quick. It's a bit longer though. No, I wish I was. I've been slipping with my work, to be fair. I learned calculus in high school. It didn't help me when I was doing web dev, Grebe said. However, now that I'm into robotics, writing my own neural networks to process images, and calculus and trigonometry are finally proving to be useful. I completely agree with you. Maths is useful if your goal requires it. It boils down to your goal at the end of the day. Yeah, exactly. Are you saying that you're better than all web devs there at you, and then web devs are all better than calculus? Is that the greater than symbol that's just left? If you laugh, you go to the C++ standards committee. I see. Yes. Oh, it's green text, right? Got you. Yeah, calculus and web dev do not go together, I guess. Pick one. All right. Enough. Let's get back into the grind, bros. I mean, obviously, that's just a message for me. You can type in chat whatever you want. That's mostly me trying to kick my own butt. Anyway, so glow compute shaders. This is very straightforward. I haven't seen that in ages, bro. Who does this anymore? That's really interesting. Is this new C++? Like, everyone suggests using the iStream buffers iterators? It's really interesting. Okay. Yeah, create compute shaders. Next, we create the data and the particle structs, the amount of particles, and the initial data in the particle. Okay, so let's have a look what it's trying to do here. So it creates a struct of data. What's in the struct? It's just lifetime. Okay, so it's very straightforward. Position, I don't know why it's 4 though. Interesting. Maybe you need that. Okay, so mesh base setup would be like this. I think we're gonna skip this. I don't really care about this, to be honest. Yeah. Yeah, we're never gonna do that. Web dev was really boring. That's the reason I made the switch. Nice work, dude. Alright, cool. That's what I'm interested in. Why would anyone use the standard? I know. I mean, literally my code. I can actually say I actually basically don't use it anywhere. Only any real chads don't use the standard template library. I use my crappy version instead. And they're following, which is way worse than the standard template library. The following is a simple emitter that can use pseudo-random algorithms seeded by a particle ID, which creates a repeated pattern. However, the number of particles, given the number of particles. Okay, so if the light, okay, so if the lifetime, okay, so what's the position? So it actually has a force here. Maybe I should start adding acceleration. That's actually a good point. I haven't added acceleration yet. So yeah, I do want this because I think, despite it being gravity based, which I can probably get rid of. So we do have velocity, but we don't have acceleration. And we have some randomness. Alright, okay, so we need the right and forward vectors to know which ways everything is going. We need the upright forward of what, though? Let's just check our music's still chilling. All you need is a raise. Not invented here, syndrome in full effect in this chat, I see, yes. Yeah, I've heard great things actually about the threading, the Win32 thread. All I've heard about them is that Win32 threads were written by the kernel writers, and often the kernel code is actually quite well written in Windows. I don't know what you could say about anything else, but all right. So where on earth does all this come from? Okay, so I'm just going to set these up. So right, up, down, left, or whatever. So let's just check our camera one and just kind of see what we're working with. I don't think it needs to be based on the camera, to be honest. So, so I'm just going to look at my camera code real quick and just see what we can work with here. Hi 52 Gears Inc. Good to see you again. Yeah, but they are real pain to deal with. Well, deal with to guess what you need from. I just finished my 5-based job system. It was a painful to do. Wow, well done. Congratulations. Got you. Yeah, it's some of the stuff in the Windows APIs is actually quite nice. From the way I got, the way it's described to me is it was written by experienced programmers who worked really hard on it, which is quite. All right, okay, let's see. So what I'm going to do, let's just concentrate on what I'm going to do for now. I'm just going to do camera stuff for now. I'm not going to say anything else about anything else when it comes to Windows API, though. I've only been told that, and I've used it a little bit, but not much. Where is game? No, it's in Foundation, I think. Yep. Alright, so do we have initial position for up, upright, and down? Why did I do this for the first time? Yeah, I'm going to look at my old engine because I want to... No, wait, that's wrong. In OpenGL, when is it... Okay. Let's just get Notepad++ up and just start writing stuff, I think. We're not going to get anywhere if we just kind of get confused. Damn. That's really sick, that, by the way. Yeah, no, I think... Alright, so let's just write these vectors in. So I'm gonna just say up is... It's gonna be very basic. I think I can... I don't think we have the C++ most vexing parse in here. I think we just have... I mean, we'll see anyway. Now, obviously, we won't have any way to change the direction of the particle effects, but that's fine. It's not down, it's... What is it called? Right, that's the one. Up, down, left, right. Let me just fix something real quick. Okay. Alright, so... Cool. Now, it's just gonna build this just to make sure that we don't get any... Yeah. I'm always forgetting what you can and can't do with GLSL. Are we good? Yep. All right. That's not what I wanted to do. I will find out. I mean, it doesn't really matter. We can always just... In fact, we actually don't need to do this at all. We can just throw this in main. It doesn't really matter if it's initialized over and over again, I don't think. Now I think about it. Doesn't really matter. Like, who cares? This is mostly for test purposes anyway. So we can start building up the particle effects I need. So yeah, I'm interested in this fella. As far as I'm aware, this is the gravity. And the rest is... So we don't have any velocity right now, so we're just going to do this for position, which I don't think is that... So we're not going to have any integration. Let me just see how this works. So we have a... absolutely no idea why we're multiplying by this, like, strange, huge value. Hello, Emmanuel. Yep. Yeah, Ratchet's there. Yeah. Ratchet's explained that. Thank you, Ratchet. I think there's a mad. I think there's a deprecated extension that does allow you to compile at runtime, but it's not the way you're supposed to do things. I think it was like a mistake. You really try and get away from that now. Standing here. So I don't really understand this. So if we, so I'm going to treat position as velocity. So right now we're just getting like a random value, multiplying it by whatever this is. So if I get velocity, I'm going to say val equals to up. Now I don't know if this is actually up, right? I can't remember what the Vulkan up, down, left, right, top, down, up, down, left, right, top, bottom. If you don't know what a caucus is, it don't matter. You still got them. Ah dear. Shout out to anyone who knows what that is. I doubt anyone knows what that is though. So I'm just gonna see. Oh, idiot! Redefining. Right, let's get the right in. Now these are all vec3s, right? So I don't need to worry about anything. Now I'm just going to multiply these by... So we need the old position. Give me a minute. Yeah, so I'm going to just take X, Y, Z. Oops. No, yeah, you don't need to do authentication because it tends to. Yes, I don't need to do if defs in my computer shaders. So Grebe has said, so you work somewhere or just full-time programming? I'm just doing this at the moment. We'll see if it goes anywhere. Probably not. I just kind of trying to focus on becoming a better programmer more than anything right now. So yeah, mostly as they say, just chilling. And what we want to do next is, I guess we can just do it by a random value, but I don't know why you'd want to do this. I don't think the multiplication matters, but sure. And then we obviously need to duplicate this, comment out this one so we don't lose this data. And so we don't do any fresh computation. Oops. Now I just want to see if this is like actually correct. So this is just val. Oh, hang on. Yeah, we multiply by Della anyway, so we actually don't need that. All right. Well, we'll see how this pans out. This might just be stupid. Right, so what on earth does that do? Where's the green one? Oh. Is that a cone or am I... The transparency's tripping me up here. Okay. That's kind of what I want, actually. This is kind of basically what I want. Now, obviously, I assume that I need to just multiply this by like 10 to speed things up before it dies. Oops. Oh, interesting. Huh. Do I need to do that for up as well? Don't think that's going to work compilation-wise, though. Yeah, kind of. Most of the particles are at 0. Okay, I don't really know. It feels a bit skewed. Right, I think what we could do actually is just simplify this like considerably by just getting rid of this multiplication. And doing vel, and then obviously just do times by 10. We don't need to do anything interesting. Yeah, I never understood this, like why why there's a break. Yeah, so why does it do that? I don't know if that's the random numberness. Now, is this going to lag everything to oblivion? Yeah. I don't really know why so many particles are at 0. I think it's probably because I have too many particles. I'm upside down now. Alright. So, how do I want to do this? Next step is... We're not sorting the particles, that's why it looks bad. Let me think. So what I'm trying to think right now is... no, you're not late. Well, I don't think so anyway. Unless the streams go down. For some stupid reason. I think we're all good. Oh, this track is... this is pretty good. Just making sure you're still listening. Still audio. Alright. Now, obviously we need to update this based on the position of the player. To always go out the back of it. So the question is, what data does it actually need? To always go outside of its butt. Yeah, so we're going to do a bit more coding today, but I'm kind of like fine with that. I think what I need to do here is... we can send in the view matrix. Let's just see how the play is calculated. Does the duck have a name? No, it doesn't actually. Feel free to name it. Have you ever considered Anki flashcards for memorization, all this stuff? Yes, I have tried. I just never really... it never really took off for me, to be fair. Just because where Anki shines, honestly, is, in my opinion, is when you're learning small bits of information, like lots of small bits of information, where it's like a lot of the information in programming is really hyper connected. So it's very rare that like, in comparison to other fields like learning a language or something like that, or I don't know, like facts about medicine or something, that like a buffer I don't know, learning what a shader storage buffer object is used for, right, would be an Anki card. Like that would need to be like connect to like 3 different ideas at the very least. So conceptually, it's useful, but I just never gelled with it, to be honest. I mean, maybe I was just using it wrong when I was building my decks. But yeah, feel free to name the docs. I actually don't mind. It's 3 docs right now. So I'm gonna get the how I'm gonna get this into the shader. That's the next question. So I need to. So when I'm moving stuff around in my shaders, I should look in here actually. Do we actually do anything interesting with our position? The only thing we do really is the actual particle shaders themselves, the actual vertex shader. Let me just change this. It's fine. I think so, yes. I would say yes, in my opinion. Second brain is probably better. But it's not the be-all and end-all. I think a lot of... That's good for conceptual building. Just because the interconnectedness of knowledge when it comes to programming. But like when you learning to apply it, you do need to start coding and kind of just leave the notes behind. So we do have this scene data here that just comes in. And I think what we can do actually is steal this, just so I don't have to think. But then we need to make sure that the scene data is coming through. And I think all we need to make sure then is that the particle... Alright, so we need... I think what we're going to have to do here is we're going to have multiple compute shaders kind of thing. Not compute shaders, multiple instances of this kind of... Yeah, this is the problem actually. Let me think for a bit. So I just need to know how to wrestle with multiple particle effects. I should mention though that learning programming is going to be quite unique for anyone else. So yeah, if you find Anki that's super useful, don't feel like to abandon it on my just because I didn't like it. There's many ways to climb a mountain, so. What are we trying to do here? So we have the particle effect that I kind of wanted, at the very least. We don't order the positions, which is still not good. What am I trying to do here? So we need the up down. Yeah, we just need the camera difference, to be honest, because the fire effect needs to be behind the camera. So you almost need like the opposite effect. In fact, no. That would be terrible. Otherwise, why would we even rent the particle effect? Emmanuel said, I've been trying the whole second brain thing as I read through the C++. And doing Travis Newman's series. But it's kind of a drag. It feels like I'm copying the source materials, no matter how I try to write my own understanding. I wouldn't know how to fix that, to be fair. The idea is that you try to never ever never go back to those resources again. That's the whole point of taking notes, that you never have to. Okay, so let me just concentrate on this for a bit. So yeah, I would just say that note taking is a pain in the ass, but it's also kind of like part of the benefit of doing this. So we need the... I'm just a faster typer, that's why I do it on the computer for taking notes. But feel free to do it on paper. No, it's fine. I'm just trying to... Sorry if I'm sounding a bit dismissive. I'm just trying to like pull... I feel like I'm getting lost here in my own code. So we need... Let me just talk through my code for a bit. Hopefully that's okay. So we have... we need the position of the players, up, down, and right values. And that needs to... Yeah, the fire needs to be in front of the player. But not behind the camera. So we need the position... Do we need the positions of the player? Is that what we're after? Let me just try something. Let me reactivate the player for a minute. I just want to see if the light is actually in front of the player. Or not. What's your physics engine? Did you write it yourself? I'm using Jolt. Just check. Sorry, minimize. So what I'm going to do is I'm going to activate the player. I haven't done that in a minute. So if I go to game, this hasn't happened in ages. So we need to reactivate this and change this and this around, and we update the player camera, not the no-kip camera. We update the player. We have the old position of the player, and yeah, we could reset the position of the player, I guess. That doesn't really make a difference. And yeah, okay, so we need to handle the events of the player, otherwise we can't move it. I think that's everything. It'll all be in here if I can find them. Yep. Yep. Okay. So now we're actually going to move the player around the screen. See if it works. I haven't done this in ages now. So the question is, I think the first thing I want to figure out is if I turn off this. Yeah, I think that we need to fix this bug first, where we have the spotlight is just on the player. Do you know what I mean? Like, I'm just gonna check if this works. I haven't done this in ages either. Yeah. Okay. So that's fine. Yeah, because the directional light is lighting up the like one side of the spaceship. All right, cool. I just have a lot of books and need to look up stuff that I need. Yeah, it's just basically the only reason I've done it that the stuff I need to look up is in here. That's the only difference. Right, got my headphones tied up in my chair. Okay, let's see. What I'm trying to do next is move the light so it's actually in front of the player. Like, way in front of the player. And then we can actually reduce the lights. So... Now, obviously, this is not going to work, but I kind of want to just test this. So, the light position is equal to the player position, apparently. But if I were to, and I put this like 100F, obviously that's not going to work because that's going to be different for every single side. But I want to see, does that actually get a displacement? Is this what we should be touching? Basically, I want to work that out first. So it looks like it's true. So if I go negative, I think it's got this straight behind us the whole time. AI viewers streamboo.com. Yeah, no. I ain't ever fucking view botting, bro. That's just lame ass. That's just the shittiest fucking shit you can ever do. So lame. Can you imagine view botting, bro? What the hell? Ah, dude, that's so funny. Yeah, I need to view bot my stream, guys. Watch out. Alright, so yeah, I think this is the thing that I want to do. Yeah, okay. So this is the thing I need to work on. Alright. I've decided to end development on PC and switch to making games for the Wii U. What? I don't know if that's serious, but that'd be kind of sick. Right. Yeah, I'm gonna get rid of this stupid comment because it's just an advert. I don't even know how you get rid of comments, to be honest. Can you just guys bear with me? I've literally never deleted a comment in my life on Switch, but someone, we're not gonna have a cringe ass AI view butter comment in the section in the Twitch chat. Hey, just bear with me, gang. There we go. So I should be able to, yeah, delete the message. There we go. All good. There we go. Figured it out. Yeah, get that trash out of here, bro. Of course, not serious. Yes, I'm on Twitch. Yes. Oh, I should. Yeah. Yeah. YouTube people, I'm on Twitch. If you want to head over there, that's also chill beans. Either chat's fine. Whatever you feel more comfortable enjoying. Of course, it's not serious. They don't even give out Wii U dev kits anymore. Sag. Yeah, I can prove them on Twitch. There we go. Ta-da! Twitch time. And on YouTube, I can prove them on YouTube, I guess, if I go here. YouTube! Yeah, so make sure you play nice with each other. Otherwise, I'll have to get in. Give you all a spank. All good. Greeb, I've recently built a project that can detect faces and more than 1,600 objects. Nice, bro. That's really sick. Then tell the user out loud what's in front of them. Hell yeah, brother. That's really sick. My plan is to put this into glasses. Can help blind people. Yeah, that sounds really cool. I don't know where Angelica is actually. Angelica's a cutie. He seems to have be doing his own thing. He was briefly in the other chat, then came to Windows, and then I haven't seen Windows, YouTube, and then went off to do his own thing, I think. All right, okay, so let's concentrate. So we have a, yeah, congrats, Garib. That's actually really impressive. Well done. I really do hope that it works out with your project. At your company. I assume you're at a company. Alright, yeah, let's not do it through that because it's the... Right, I'm just going to change this all to C so I can actually see these languages. So I can switch between the shaders. Okay, I think we've paused the music by accident. Let's change the song. Yeah, Challenge is sick. Let's go on that one. Super, super underrated soundtrack. Oops, I didn't restart that. I think I'm on development now more than anything. I could get one. I could get a Switch One dev kit if I wanted to, but they're like 500 quid. I see. Particle C, yep, that's fine, and there we go, and there we go. Really? They don't sell any dev kit to indies? They're probably scared that they're going to pirate them or something. Okay, done that. Exception of Toby Fox. Thank you for the lovely 2 jewels there. Lovely star for 2 jewels on the YouTube chat. Thank you very much. Thank you, Gemma. Hope you're having a great day. Whatever you're doing today. Alright, so it's always a pleasure for you to join us in the stream. Right, so we have the particle effects. We need to move the... Where's the core shader at? So where the light, where's the actual light? So we have the spotlight. This is just a demo stuff. Yeah, that's very true. We haven't done the thing that Ratchet has suggested in the Discord yet, so just excuse that. Probably to reduce the amount of slop on the East Store. Fair enough, yeah. I mean, remember when Steam used to be like that? Trying to be super selective of what could be on the Steam shop. Now, I can even go on there and post stuff. Damn. Shit has gone downhill since then. Anyway. What am I trying to find here is the light. Okay, so that's the lighting direction, which is fine. Where's the spotlight direction, which I'm actually trying to find here? That's the directional light. Spotlight. So n.l. Where's the light itself? I think I'm doing some pointless calculations here. What's L? What's little L? Huh? What is this for? Why are we doing L and then another L? Why is there 2 L's here? Give me a sec. This is kind of confusing me. Why is there a lowercase and uppercase L? What does that do? So I might have broke my lighting here, but I have no idea. Does the spotlight still work? Yeah, I don't know what... Okay, so that just changes the... Alright. Alright, cool. I don't know what changed, but yes. I think we can get rid of this lowercase directional vector thing. I think we still do... Do we still use this for anything? Lighting direction... No, we don't. Okay, so we're not even using these, I don't think. So we're just doing a pointless calculation. Let's just check. Yep. All right. So yeah, obviously we're going to try and move the... We need to put stuff around the play that makes sense. All right. Okay. But we need to put the spotlight. N.L. So N.L's here. Normal, which I think comes from the normal matrix, right? We normalize N, and then if we have a normal texture, then we basically sample that. And the TBN matrix, which is slightly different. Yeah, we also have a half vector here, which... Why are we doing that? What is happening? Is that doing the same maths? It is doing... Okay, so we have like a redundant variable here. I bet I was debugging stuff for a long time. That's why there's a bunch of like leftover maths. I'm just going to put this down here so it's actually easier to figure out. I don't think we use H anywhere, right? That's a good point. Just make sure we're not using H. Right, okay. So we have a lot of lowercase h's, which we need to fix. Not that it matters, but... Get our half vectors in here. Where's the other H? Here. I think we're good. So that should be exactly the same. There might be something I've missed, but we shouldn't see any difference at all. It's going to go into a rock. Yeah, we can see the... yeah, we still have super high light intensity. Alright. Next is... Okay, so we've done that. Now we need to go back to what I was trying to do. So spotlight... So obviously the spotlight is tracking the camera. Yeah, okay, so we have the scene I, which is the lighting direction, which is where we are exactly. Negative. So we do have scene data in here, which is fine. What we need instead, though, is the player position plus kind of like whatever it is a little bit further out, you know? For the spotlight, anyway. Because it's not an FPS camera. It's a third-person camera, so it's not... This would be great for a first-person camera. Yeah, so where is our... So we have scene data in here. What's our scene data? So scene data, what's the struct? Alright, so for our I think what we need to do is not have... so the light... Oh, no, wait. We need... no, that's the other way around. We need the light... right, let's look at that again. Minus position. What's the V position? Alright, I'm just going to obviously break this and just see, like, where are we relative to everything else, right? So I think what's happened here is the spotlight is not moving. Okay, yeah, okay, that makes sense. So we don't correctly get the spotlight. Yeah, so the spotlight is not moved. I need to figure out exactly... V position minus the light position. Position to light. So we just need to move this forward, effectively, in front of the player. So I'm just going to try a couple of... Again, I just need to remember how this part of the lighting equation works. Yeah, so I think it's the same deal. If I go back to here, we should see kind of like a weird... Where are the particles? Yep, so we have a light that doesn't move, which is fine. Which is... Whoops. That's wrong. Let's get rid of this. And... Go back to our compute shader. This is a good track. But let's change it. Let's change the music. No Russian Clank. I feel like I've got too much Russian Clank music, honestly, in this playlist. This is good, but it's a bit goes on a bit, to be honest. Let me pick like my favorite track. My peak song in this playlist, which you guys have heard to death, but I love it so much. It's not this one. This is just nostalgia mostly. Oh, I keep going. I think I've gone past it. You know it. It's the final battle from Lufia. All right. Cool. Hello, bro. I have no idea what you are making or what's going on. I am making a little space game with a game engine I made. I'm trying to get the... So let me explain from the top. This is a bit more of a study because I'm going to explain everything. So, we're making a game engine in C++ and Vulkan, which C++ is a programming language, and Vulkan is the API that talks to the graphics card. It's going to be a 3D little game. Stuff is not finished yet. So I'll show you what that looks like at the moment. So I'll go full screen as well. So if I change this. So this is our game at the moment. I should actually show you the... So this is the main menu. This is a 2D renderer. It is not finished, as you can probably work out. So go into here. And we have our debug geometry, which tells us where the collision is. This is our player. Obviously, we haven't got a spaceship here, but we're going to have like a little spaceship with stuff coming out, which is going to be cool, I think. That's what we're working on right now. We have a nice little spotlight, so if you're heading in a dark direction, you would hopefully be able to see the rocks before you crash into them. It's not going to be the most groundbreaking game you've ever played, but it's going to be a game that you should be able to kind of like enjoy for like a couple of minutes and then put back down, I guess. We're going to hopefully add more stuff into the game. It does have music, by the way. I just turn it off for your viewing pleasure. That is what's going on. That is what we're making. It's going to be, it's going to be it's going to be just a little game. We're trying to fix this lighting at the moment. As you can see, the duck goes completely white, which means the light is not where I need it to be. It needs to be in front of the player, not... I don't exactly know what's going on when I go in the other direction. So yeah, I'm trying to work on this at the moment, trying to make this like this light work a bit better. I don't think the offset is very good. So yeah, when you crash into the asteroids, which is the polygon mesh, it does disappear. Eventually, that's just to test bullets. Eventually, you'll be able to shoot stuff. And crashing into the asteroids won't delete them. That took actually a long while to get working, so yeah. Currently working on particles and trying to get the lighting to work. As you can see, I can't stop moving because this is a spaceship. So yeah, trying to get this to work. So hopefully that explains it. 5 gallons of water. Thank you for joining us, by the way, and great question. Yeah, I am as one of my favorite music plays. If you don't know what a game engine is or anything like that, just ask those questions as well, and I'm so totally happy to answer them. Get some water. You fully understand. Fantastic. Anyways, I just passing by, but this does seem like a really cool stuff. Thank you. Good luck on the rest of your progress. Thank you. Yeah, thank you for stopping by. I hope you have a good rest of the day, dude. It's always a pleasure to meet nice people. Anyway, right. So we have. Right, so weirdly we are getting like way... Hang on. I think that's the directional light, actually. Yeah, if I change the directional light, I don't think it's going to be the same. So if I go into my light shader and change the direction... Oops, wrong. It doesn't really matter the direction, I guess. What would be the opposite? I'm just going to change the signs, I think. So we're just going to get the opposite way. I have no idea what a game engine is. No worries. Oh, a game engine. Yeah, let me explain. So a game engine. What is a game engine? Good question. So there's two types of game engines. I should point out straight away. But it's an engine. An engine, I say air quotes. It's just a piece of software, effectively, that drives the game, right? If you can imagine, games like Pac-Man, for example. They have a Pac-Man game engine. It's a bit of a strange way of thinking about it, but the underlying software that's interacting with the operating system that isn't really doing the gameplay mechanics themselves, anything that isn't gameplay specific, right, is part of the engine. So graphics, for example, would be an engine thing. That the boundary between the game and the game engine are quite blurry, admittedly. So right now I'm making something... it's closer to just a game, right? With some common utilities that I can use for other games. So, yeah, there are tools out there called Unity and Unreal, which are commercial, free products that indie game developers use. They're typically the most popular, and they are pieces of software that you can use to make a game with. Now, my game engine is going to be very different from that. It's going to be very specific for my game, and that means that it's less customizable and less flexible, but it allows things to be quicker and more efficient, and I don't have to write like thousands upon thousands upon thousands of lines of code to accommodate for things that I don't care about. For example, I don't care about networking. Whereas Unreal and Unity, which are game engines that anyone can use, they do have to care about networking, right? So what I'm trying to do is a very game-specific game engine. And again, a game engine is just something that drives the underlying game itself, right? So that's what we're doing here. It's typically harder than writing a game from, using a game engine. And... Hi, Venge. Good to see you. But that's fine. It is what it is, right? It's I like making software this way. Many people do, and I think it's a bit of a lost art. But I think I've got a nice community that all loves this kind of stuff. So yeah, all my homies hate networking. Yeah, such a pain in the ass. Yeah, well said, boy. So yeah, that's what hopefully I explained what a game engine is and what we're trying to make here. So we're trying to do two things at once. We're trying to make the game engine and the game, and the line at which we're trying to make. So right now I'm working on game specific stuff, but before that we were working on game engine specific stuff, which is the particles, right? The particles you can see in the middle of the screen are these like blue and green like fountain things that are popping. Where are they? These things, right? These are particle effects that just keep spewing. Sorry, they keep should you know, that they keep spewing nice things into the scene. Yeah, so that's they're particles, and now I'm trying to work to make the game a bit more playable, right? So yeah, the separation between a game and a game engine sometimes can be extremely blurry, if not basically the same thing. Are you from Australia? No, I'm not. I'm from the UK. I'm the other side of the planet. Have you considered restarting the... I might go into Vulkan to love that Spider-Man lifts. Boy has said, do you work in the games/entertainment industry, or is it just a passion project? The latter. I have never worked in the entertainment industry. I have been a programmer before. I have been employed as a C++ programmer, but never as someone who works in the video game industry or anything like that. Yeah, good questions all around. Have you considered restarting the project in binary? Yes. I have an engine actually that I'm going to start right now. It's called the binary engine. So yeah, this is how you write a game in binary. So what do you think? Oh, I've made a mistake. Hang on. There we go. Okay. No, I'm not going to do that. Yeah, I love Spider-Man list that you're going into Vulkan. I hope you have a fun time. Feel free to reach out to people in our community. I'm not. I would say wholeheartedly that I'm not. Oh my god, he's finally lost his mind. Yeah, I'm not necessarily even the best Vulkan programmer. So you know, if you do want to start with Vulkan, feel free to join us. There's plenty of jackets spare for our Vulkan journey. And again, for Vulkan is the graphics API that I've chosen that talks to the graphics card. It's considered quite difficult. I think it's cool. All right. What's our timer on? It's on 7 minutes, and it is cool. Ah, thanks. Yes. I think it's cool too, boy. Ozen. Okie dokie. Aside from bugs, I almost finished. Jack's playing Vulkan is great. Need more people building with it. Yeah, it's a great piece of I do like. I mean, it has some annoyances here and there, but I definitely like it. Considering all the control that you get. Aside from the bugs, I almost finished writing a Wayland client for a program, said Spider-Man Lift, but it's currently software rendered, so I'm leaving a lot performance games on the table. I'm sure, well, here's the thing, right? I talk about this a lot. You know, I say I'm making a game engine, right? I can cut out things like I don't need, like networking. Maybe Spider-Man lifts that despite you leaving performance on the table, you could argue that it's actually better that you leave performance on the table in some situations, right? Sometimes optimizing software to the point at which it never gets released is worse than making it slower, right? So it's not always... I love performance, by the way, and writing hardware accelerated stuff, and maybe that's what you want to use Vulkan for. But if you've written a good software renderer and it works, and it does what it needs to do, sometimes that's enough, especially if you're just doing it by yourself. You know, because like I said, I don't have to write an entity component system if I don't want to, right? Despite that's what everyone says that you should do. Like every engine needs an entity component system. Like it's like in their Bible of like things that you must do when you're making a game engine. So that's all from the YouTube chat. There we go. Okay, so what are we trying to do then? Let's try and remember. All right, go to this. Yeah, I want to close all these shaders because I'm not editing them in this anymore. Okay. So, yeah, we need the directional light. Oh, yeah, we changed the direction of the directional light. I want to see if it completely goes white in a different direction, right? All right. No idea. But I think it still goes white. That's the thing, the duck. So it is, because I am adding the lights together. I just think in this, let's just see what the light looks like. Because I've changed the direction of the light. Right, I think the reason I didn't like this is because it's all black in the blackest direction, right? So let's move that back. I don't think it makes any difference, the direction, but... My plan is to work on the Vulkan implementation bit by bit and still work on the features. Ah, okay, that's actually quite smart, yeah. Yeah, so it is just white in a couple of directions. Alright, cool. Right. Check the music's still good. Okay, looks like it's decided to pause on one of the best Spyro tracks. Sag. Okay. Right. So again, I need to figure out the direction of. So where's this position coming from? So if I go into the core shader vert, we're passing this over. And what is it? Okay, so it's the global model times by the model position, which has come from where? So this is the... Okay, I've used this once. Oh, I see. No, I've used it twice. Okay, so this is just the instance model times by whatever this is. Where does that come from? It's been a while since I've been in the core shader stuff. So yes, we have an old style uniform buffer object type stuff for accessing this buffer. So it's still using a descriptor set layout and all that kind of jazz, like in old school OpenGL. I think we should also get rid of this as well, finally. I think we always set the color. Let's just check. Let's just make sure. Hardcore no part. Yeah, some of my homies hate particles as well, to be honest. Has been pretty annoying, but it is what it is. Alright, cool. That's fine. Just wanted to make sure that was good. That was mostly there for testing reasons. So we have the position times by the model equals model position times by the global scale times by the vertices equals the V position. And then that comes into here with a vec4, looks like, yes. Because that is a vec4. Yeah, if you multiply matrix, 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 vector 4, assuming that it's a vec4, 4x4 matrix, then you get a vector out of it, which is the which is what we're interested in. Then we go into here with the V position. We minus that from the current light position. Now, the light position is supposed to be the player position, it feels like. Oh, you sick, boss? It sucks when you're sick. That's a YouTube chat person. Being a bit ill. So we have data, lights. Scene, reference, data, lights. Let me think about this for a minute. So this position to light is that. Let me normalize it. What I'm trying to work out here is what needs to be... What needs to be changed in this equation? What in this equation, what needs to be changed? Let me think. So if you want to use the forwards vector to kind of offset this a bit, maybe it would make sense in this particular case to... Yeah, because we would need to... If I look at my particle shader, we need to do something with the camera. It can't just be... and we probably can do this in a vertex shader, actually, because we don't just... and if I look at the particle... so you've seen view... Because it always needs to be in front of the player. So if I have the position minus the light position, the light position is right now, I think it's the player position. Okay, so I'm going to change this a little bit in my code. I'm a bit trying to figure out. So if we have a here, right? So the light position is equal to what? Yeah, it's just equal to the... it's the directional... Oh, interesting. Is this already solved? I'm just not moving it far enough. I need to go... Yeah, I'm going to turn off directional light, I think. Alright. Have you mastered the art of Blender? No, I barely know how it works. Okay, so let's turn off the directional vector. Sorry, let's turn off directional light for now, because this is getting a little hard to see. Wrong. Sorry. I need to not use this because I can't see any syntax highlighting at all. So if I go into so the directional light is really easy to turn off. That's it. You have a question? Sure. Feel free to ask. Interesting, okay. Wait. So we turn off the directional light. So when I go near an asteroid, we should see... Oh, okay. Huh. It is lighting it up, but it's not... We've lost a lot of... It's not as intense. It's actually like reduced considerably. Alright. Interesting. So if I go into here and change this to 1, I guess it doesn't do anything. Why are GLSL shaders most of the time in frag and vert? Should they be .glsl? That is for the compiler. So if you look at my CMake, it figures out basically what to do based on the extension. So the stem, you know, goes, okay, get the file name. I don't have to say, like, for example, I think if I didn't specify any file extension, I would have to say, like, vert, right? When they're GLSL, before they're compiled, GLSL knows what frag means. There is a way to do glsl.frag or something like that, but you need to do a bit more CMake shenanigans to do that. I just felt it was easier just to not have GLSL in the extension. It's because these get turned into intermediate files called SPIRV, and the SPIRV files are then taken into the graphics driver, then compiles them further into binary to run on whatever, you know, AMD, NVIDIA, whatever. And so it needs to know when you decompile them. You can decompile SPIRV. It tells it like what type of shader it is. And this is, I believe, is gonna be. It's gonna. I don't know what the compilers do on the with the SPIRV, the intermediate representation file format. I don't actually know what that compiler is doing, but it's going to use data that we've passed in to say, oh, this is a vertex shader. So the input and output variables are these because it's a vertex shader and stuff like that. So we need to tell basically the GLSL validator what it is, so it can compile to something that makes sense. Hopefully that clears that up. Oh, whoops. So yeah, frag means fragment shader, vert means vertex shader. If you're familiar with these ideas, if you're not, I can always let you know. I can always explain what these mean. Because I know not everyone here is a graphics programmer specialist or anything like that. I wouldn't call myself a specialist, but I at least know something. I know a thing or two about graphics. I'll say that at the very least. Probably I need to know much more, but there we are. All right, so if I even change the intensity down considerably on the directional vector to 1. What do we get? Ah, okay, so is the intensity super high though? Huh. Ah, I'm an idiot. I just realized that the light went behind us, didn't it? That's what's happening the entire time. I'm a doofus. So if I do a -10, then it should be exactly where we want. It should be in front of it should be in front of us. Oh no, okay. I think it needs to be more. But it's close. It's close. Yeah, it's lit up the bottom, which is not ideal. Let's go with 20. No, okay, interestingly. It hasn't changed at all. I don't want it to light up the... okay. Let's do something silly then. Let's do 100. Right, obviously it should not be visible at all. Now the light should be miles and miles ahead of us. No, okay, it's not again. What? So it feels like this is the same. Maybe we're losing some sign here. Oh, I'm making a mistake again. Leave that alone. This is the thing I need to be scaling. Sorry. Okay. Yep, that's exactly what we needed. Oh, that's perfect, actually. That's exactly right. Alright, let's turn on a... Let's turn on the directional light again. Okay, so that was super, super cool. Immediately that worked. What am I doing? I'm just doing it again. I need to be editing this. So you should see the directional line in. And we do certainly see that. Yeah, and now the spotlight is directly in front of us. It's not lighting up the... Because it was messing up the... It's messing up everything. And if you fly in the void... We can see it's very much lining up the asteroids much easier, which is good. Now we need to do basically the same for the particle effect. So we constantly need to be. So I don't think the. Let me think about this. Let's try it. Let's try it. So the particle set data. So when we actually do the maths, what do we need in here? I am trying to update the position every single frame, so we need a... So if... Okay. Now we need to put the particle behind the player. So what I want to do here is change the, not the velocity, but oh, I'm looking at the wrong thing again. It's all black and white here. All right. I might take a lunch break in a minute. Hopefully hopefully I don't pass out from eating too much food like I've done in the past. Right, Right, so what I'm trying to do here is figure out, like, what do I need to move here? The forward, right, or up? I think the direction is up. No, it's forward. It's definitely forward. And what I'm going to do, what am I trying to do here? I need like a persistent value. All right, so let's just move. Let's just pretend I've moved forward, right? I've moved forward by 1 unit. What does that do to the particle effects? Okay, so that actually changes. I've got to be careful here then. It's the position. Oh, I'm being a doofus. That might be useful, but actually what we need to be editing is the particle vertex shader, yes. This thing. Yeah, because we have a this thing, which is the important part. And if this particle set has its transform updated all the time, which I don't think it does at the moment, which I might just break one of the rules of shader programming and just try and update it every single frame without making 2 buffers anyway. I know that's not correct, but what I'm going to do anyway is just see if I can take the particle data and try and update the particle set position every single frame. Now we need both rotation and no, we don't. We just need the directional vector here. So when we update the particles, what I'm trying to do here is mess with the particle transform logic, which is this. So particle sets. So we should be able to do something a bit terrible here for now. So good, we do have update particles. So we might be able to do something like particle set 0 dot transform is equal to, I don't know. Yeah, let's just throw this in here. Like we can. Yeah, let's actually do the maths that we need. So we need the directional vector. So we need the directional vector. Nope. Vec3 directional vector. Yeah, directional vector, right? I say vec, it's a bit, we know what that is. And I'm going to throw this in here with the vec3. So I'm just going to take and what we're going to do is yeah, we're going to do this, and then we're going to multiply this by this directional vector. Don't think equals makes any sense. Oh, I mean, we can make it back forward. It doesn't really matter. I don't know. Either way, we're going to have to do some conversion. I think I'm just going to do it here. I think it's going to be easier. No. When we actually do the directional vector, it is a vec4, I think. Oh, it needs to be 4s as well. There we go. And that should resolve. And it's a... goodness sake. Right, whatever. Alright, so that's going to transform it. Now I'm just going to do the laziest. If I take the transformation vector, sorry, the directional vector of the camera, which is this light position thing, and I pass this. Is this a vec3 or vec4? Okay. We will pass in. We'll do this then. Doesn't really matter. Where's the error? Oh, okay. So this is a. Where are we? Yep. And we need to take this and then put this here. Oh, no. Vec3s. Directional vec equals that. And I'm going to make this plus 10. So it is behind. Actually, I'm going to make this 1 for now. I don't know where that's going to live, but hopefully we shall see. So that's going to make a transform based on that. And it's going to be particle 1. I have no idea what this is going to do, but we'll see. And then we'll have to make a small pit stop after this, I think. So this might just break. I have no idea. Doesn't seem to move anything, which is interesting. Okay. Really? Now, obviously, we don't have a... Oh, have I made this device only? I might have made this device only, actually. Which means updating this does nothing at all, because it's not host coherent. So, the particle set size is... Is it a GPU buffer? No, it's not. Okay. Oh, I'm not writing the data back out. Let me just grab that then. Not that. Where do I put this code somewhere? Oh, it's not here. Okay. We definitely need to write this data back into the shader, right? Rather than just updating the position. This is what I'm after. So after we've changed the position, then we need to get a particle renderer and actually write out the data change. Yes, I know this is a terrible idea. There's a couple of things I'm doing wrong here on purpose, just because I want to, because I've never had any particular issue with this. If you know what I mean, right? So, oops. Now, please don't do what I'm doing here. I'm updating a buffer every single frame that could be used. Hey, I couldn't follow as closely. What technique are you using for particles? Can I explain it just? I'll explain that just in a moment. Oh, so when you say particles, do you mean in general? I can just say compute shader based particles. So particle set, but I don't know if that means anything. But I'll explain in detail a bit more what that means. So we need the can we just access to the data? Yep, let me do this particle set. And then we need to take this, say the size of it, and this is a so hi the big loose goose. So let's just grab this fella and just make sure it multiplied. So what I'm trying to do here, by the way, is update one particle set so it's constantly moving, aka an emitter. So I'm changing the position based on the directional vector, and we shall see if that does anything that we care about or want. Redefinition of particle set buffer. Really? Oh, you're right. Yeah, okay. Never mind then. It's a good job I did that twice so I can avoid shadowing. Alright, so hopefully, because it's CPU based, host visible. Yay! Woo! There we go. We are getting there. There's obviously way too much. But as we move around the scene, we are taking our particle with us, which looks a bit odd. It's not rotating with us at the moment, but at the very least, we've got it tied to our position, which is good. So in theory, it should be behind us, right? But it's way too aggressive right now. So we should see like a tiny little particle. But that's good. It's like a comet almost. But it doesn't really make sense other than... yeah. Anyway. Yay, indeed. Okay, so... Yes, I'm trying to make a particle effect that comes out the back of the spaceship, so it kind of looks like fire. Surprising, that's what it's there for. Obviously, it's not rotating with us. Nothing is, but that's fine. We'll fix that shortly. So what technique are you using for particles? So generally speaking, my general... let's just make sure the music is playing. I'm going to change the track. This is a bit of a long one. Let's go with... you can't go wrong with Simon Belmont's theme. So I'm trying to make the GPU handle particles, so we don't have to render these on the GPU. This is an efficiency thing where we don't actually have a bottleneck on the CPU. So we're doing indirect draw calls. We're filling up the indirect draw calls with instance-based particles, meaning that for each roughly 20,000 particles on the screen, I should say 1,997, 19,997 particles are instance drawn. Every single time we have another set of those, we have to make another draw call because it does get inefficient eventually once you instant draw. And yeah, that's the idea. So we have this compute shader that's doing the maths to push the particles out. And once we've done that, then we generate the draw calls based on how many particles are on the screen. And right now we've got 2 draw calls. We're not perfect yet. The buffers that we're filling up aren't very good. But anyway, that's... I'm kind of wanted to, do something slightly different today rather than worrying about the engine side. I want to see if I could actually use what I've already made. Yes, so that's what we're doing right now. The actual maths is just kind of generic compute shader stuff. So this is the compute shader. I should go in here actually. So this is the compute shader doing the simple integration for linear integration for velocity. And this is doing the computation to generate the draw calls that are all generated on the GPU, and each of these have a buffer that we kind of write to different parts of the shaders, and then that goes into the vertex shader here, and that then goes into our fragment shader. Now our fragment shader is literally doing no lighting at all. I'm not worrying about lighting yet. And I've separated my physically based renderer lighting thing from our particles for now. That is a performance win. I don't really see the benefit as of right now for the game to have physically based rendered particles, unless I'm doing something kind of, because they die so quickly, and you're not going to really be paying attention to the particles outside of a couple of things. And as you probably know already, if I fly, so I can actually keep them with me this time. If I'm flying around, you can see that they're basically spheres. They're actually a sprite that's a circle. It's just a 2D image which is always facing the camera. So if I spin around, these rotate to face the camera. Now, of course, this isn't ideal. Because I haven't sorted out, because they have transparent parts, these textures. I need to sort the particles in another compute shader. I think I actually don't know yet. So if there is a transparent particle in front of another particle, that needs to be rendered first, effectively. So we basically go, okay, instead of just doing it in any order, which is what's happening right now. That's why we get like, it almost looks like bubbles. And that's why we don't have any like clean blending together. So we need to work out the order of which these particles live in. So yeah, and obviously the thing I'm going to work on, I think after lunch, is rotating the vector. Rotating the particle so it's always behind the camera, which is going to require some other stuff that we're going to have to do. But yeah, generally speaking, that's what we're trying to do. That's the technique. In theory, we can render a million particles based on this technique. We're rendering quite a lot right now. We're rendering. This is 20,000 particles. There's if I go back to the center of the scene, there's another 20,000 particles just spewing out as well, which are green. Yeah, so that's what we're gonna do. So this is a bit overkill. You wouldn't probably have this many particles for what we're trying to replicate, but it's fine. Yeah. So there's a couple of things we need to do. So what I'm going to do, guys, is I'm going to pause our music. Sorry if anyone is enjoying that. I'm going to pick a video on maths, and I'm going to watch that instead while I eat my lunch. I'm going to go and push to talk. For people on Twitch who've never seen my stream before, I want to watch Zero to Geo. A Zero to Geo video. I haven't seen these in a while. On geometric algebra. I don't exactly know what we're going to watch. I might just start from the beginning and kind of work my way through. Yeah, this is important that I know this stuff. So I'm going to watch this. And remember what a trivector and bivectors are and all that kind of stuff. That would be cool to watch. I was wondering what could do draw next multiple transparent objects. Yep. Should I just sort them by distance each frame? Won't it be expensive? So yeah, there's a couple of ways of doing transparency. If it's static geometry, you don't have to worry about it too much. It's not too difficult. You just have to do transparency first. Sorry, other way around. You have to do transparency last. What am I saying? So you do all your opaque geometry, and then you do the transparent geometry, right? Now, the order which you do individual transparent objects is kind of tricky. There's an unordered way of doing it, and there's an ordered way of doing it. But effectively, yeah, in the ordered way of doing things is you basically just order your transparent objects in reverse order. So you render one transparent object, which is the furthest away from the camera after you've rendered all your opaque geometry, and then you work backwards, right? Rendering more transparent objects. Well, I'm going to play some games. We'll be here soon. Thank you. Well, good luck on your games. Hope you crush it in whatever game you're playing, or have fun at least. Yeah, so we're going to watch Zero to Geo. I'm just going to grab my lunch because I need to study this stuff. Yes, I'll be right back, gang. It is 2 o'clock. I have not eaten since 2, which is kind of crazy. And I need to keep eating because I'm, admittedly, I'm weak from the gym. I overdid it. Okay, so I'm just going to bring my stuff over, and then I'll go and push to talk. My size per vertex dropped from 24 to 28. Let's go. So you're packing them to reduce bandwidth. Very good. Yeah, quantize those motherfuckers. Wow, that's intense. That's a save of... Yeah, that's sick. I need to quantize... I've quantized my textures, but I haven't quantized my vertices. Which I could probably easily do. It's not... Quantizing stuff isn't too tricky. But yeah, that would... Yeah, that's kind of cool. It saves a bunch of memory. So anyway, we're going to watch some geometric algebra. Feel free to talk in the chats. Say plural right now. While I eat my lunch. So again, yes, we do have Twitch and we do have our YouTube, which is very nice. All right. Hopefully you guys enjoy this. Yeah, I think I've done octagonal encoding before as well. Yeah, well done, Ratchet, on honestly and getting your shaders working. Sorry, your vertex buffers. Let me turn this up.
Geometric shapes. In school, we first learned about elementary arithmetic, where you add, subtract, multiply,
change
and
things
divide
a bit. This is
numbers.
my Windows noise.
We then later learned elementary algebra, where we started describing these operations on arbitrary numbers. This allowed us to start finding equations that were valid for all numbers.
If that's a bit quiet, let me know. I'll restart the video. Right.
Geometric algebra is an incredibly powerful branch of mathematics that extends the usual operations on numbers to geometric shapes. In school, we first learned about elementary arithmetic, where you add, subtract, multiply, and divide numbers. We then later learned elementary algebra, where we started describing these operations on arbitrary numbers. This allowed us to start finding equations that were valid for all numbers. Similarly, there is geometric arithmetic, where you add, subtract, multiply, and divide shapes. This leads to geometric algebra, where you start describing these operations on arbitrary shapes. This allows you to start finding equations that are valid for all shapes. Geometric algebra provides a natural way to convert geometric problems into algebraic problems, which can be much easier to solve. For example, reflecting a shape across a line uses this simple equation. Geometric algebra is useful for more than geometry, however. Many problems in areas like physics, engineering, mathematics, robotics, computer graphics, and more are geometric problems, so geometric algebra provides solutions in all of these fields. Geometric algebra is actually a fairly recent development. Back in the 1800s, many different algebraic systems to describe geometry were popping up. In the end, the one that came out on top was something called vector algebra. Vector algebra can describe many things, but there are certain situations where it is not enough. Many people started tacking on new mathematical ideas to try to fill these gaps, and while they did manage to be successful in describing more than vector algebra could, the result was a massive kludge of many separate ideas. This situation makes everything hard to understand and learn. This problem began to be resolved in the 1960s, when David Hestenes started using geometric algebra in physics. Since then, geometric algebra has been applied to many other fields, providing many new insights and unifications between disciplines. Geometric algebra accomplishes this by being one simple framework that encompasses all of the others. You might think that this makes geometric algebra more complicated than the alternatives, but it is usually the opposite. While geometric algebra can get a bit complicated at times, in most cases it doesn't get any more complicated than what you would have seen using something else, and in many cases it is simpler. If geometric algebra is so useful, then how come it doesn't seem to be used that much? One probable reason that geometric algebra is not used at lower levels is that there is not much introductory material for it. Most introductions are only found in scientific papers that are way too dense for a beginning student. These papers are usually explaining how to apply geometric algebra to an old problem so that people generally have to learn topics without using geometric algebra before they can learn them with geometric algebra. This causes professors to not care about geometric algebra, and so then there is nobody to teach the students. I am hoping to remedy many of these problems by making this video series, From Zero to Geo. We are going to start at the level of high school algebra, and from there, completely develop geometric algebra from the ground up. This will allow students to learn geometric algebra and to use it to solve problems before learning the alternatives. My hope is that this video series will be good enough that it could be used as a textbook for teaching geometric algebra to people who only know high school algebra. You might be wondering why I decided to make a video series instead of writing a textbook. There are two main reasons. First, videos are generally more engaging than books, so hopefully a video series will be easier to use than a book. Second, by using videos, I can animate the many geometric objects that are used in geometric algebra. A lot of the writings on geometric algebra tend to focus on the algebra part of the field rather than the geometric part because it is hard to describe geometry through writing. Using videos allows me to fully integrate the geometric aspects of geometric algebra with the algebraic parts, allowing for a better and more complete understanding of the subject. Before we move on, there is one important clarification that I need to make. There are actually many different flavors of geometric algebra. Each of these flavors has their use, and some are better suited to certain applications than others. Because some people only care about a single application, they only focus on a particular flavor. This can confuse beginners because some terminology has a different meaning depending on the flavor. For example, vanilla geometric algebra says that vectors are an oriented line segment, while projective geometric algebra in 3 dimensions says that vectors are a plane. Despite these differences, it turns out that the equations are almost exactly the same in each flavor. But what flavor should we focus on?
Ah, yes. A vector is a plane. Oops.
To start off, I am going to focus on vanilla geometric algebra, usually called VGA for short. It is the simplest one, algebraically speaking. When you see people talking about geometric algebra, they are often just talking about VGA. Once we have explored VGA enough, I will start to expand to other flavors. Because this is going to be like a textbook, that means that there will be exercises assigned. When you see this pencil symbol, I want you to pause the video, get out a pencil, and get to work. One of the best ways of learning is doing. If you don't do the exercises, you will not learn the material. The only excuse for not doing the exercises is if you don't want to learn. I'm going to be providing the answers to all of the exercises soon after giving them, so make sure you pause before the solution is spoiled. The types of exercises are varied. Some are purely computational. Math isn't about computation, so I don't like.
This field is too split. We need to make something that combines everything and can split itself. Yeah. It's yeah. The excuse is going on steroids. I like that. That's really funny. Although it is quite good, geometric algebra, if you haven't actually gone through it. If you ever heard of rotors instead of quaternions, this is why. This is where it comes from.
These kinds of problems as much, but they can be useful. They can solidify the concepts in your brain, and doing them enough can make you fast at computing. Also, getting a question wrong can sometimes show you where your understanding of the subject is hazy. Depending on the situation, I will sometimes talk through the solutions of the problems, but at other times I won't. I will always show the answer though. There will also be exercises asking you to explore a new concept, or to try to prove some statement.
Okay, with these earlier exercises, I've already done a lot of them. So for me, this is mostly revision.
If you haven't done much math, these kinds of questions might seem strange. However, they are one of the best ways to learn mathematics. They are the kinds of questions that mathematicians try to solve. When you come up to one of them, try your best to solve it. Some of them are going to be too hard, and I might even sneak in a few that are impossible. The point of these problems is not to get the right answer, but rather to get you acquainted with thinking in terms of geometric algebra. If you can't figure out one of these problems after trying everything you can think of, you can continue on in the video and see the solution. Also, if you're afraid of proofs, don't worry. I am looking for an argument more than a proof, and I wouldn't even consider my own answers to be good proofs. Here is a brief outline of my plan for this series. We will first learn about vectors. In VGA, vectors are thought of as oriented line segments, or an arrow. However, in more general contexts, vectors can be used for a lot more. We will also talk about these other uses. In geometric algebra, vectors are the foundation that we build everything else on. We will then shift our attention to multivectors. Multivectors are the main object that we use when doing geometric algebra. While multivectors can represent geometric objects such as lines and points, they can also be used to represent operations on these shapes. After developing the basic objects that we do geometric algebra with, we will talk about how to multiply them. The multiplication that we will develop is called the geometric product, and it is what sets geometric algebra apart from everything else. We will also see how the geometric product naturally encodes rotations and reflections. We will then use the geometric product to define several other useful products like the inner and outer products. After this, we will move on to the other flavors of geometric algebra. In the process, we are also going to learn about alternative geometries. Then we will talk about linear transformations. Linear transformations are generally a topic in a linear algebra course. However, geometric algebra provides many insights into the study of linear transformations, so we'll cover that here. Finally, we will formalize geometric algebra and rigorously prove that everything we have been doing is correct. This chapter is optional for most people, being included mainly for the professional mathematicians. One thing to note is that I haven't actually made these videos yet at the time of recording, so it's possible that this plan might change slightly. I am going to put a table of contents into the description of this video that I will fill in as I make more videos in the series. With all of that said, I hope that you will join me in discovering geometric algebra. In geometric algebra, we do algebra on geometric objects. So to start off our journey in discovering geometric algebra, the first thing we need to determine is this. What is the simplest geometric object that we can do algebra with? Trying to answer this question will lead us to the idea of a vector. In this video, we are going to get our first understanding of what a vector is and why we care about them. This video is a part of From Zero to Geo, a series where we formulate geometric algebra, an incredibly powerful branch of mathematics, from the ground up. So what is the simplest geometric object? I feel like you can't go wrong with points. However, how could you do algebra with points? For example, if we had another point over here, how would you add these 2 points? How would you multiply them? Just looking at this picture, it doesn't seem too clear how you could do this. Well, here's something we can try. Let's draw some axes. Then the coordinates of the first point are -1, 0, and the coordinates of the second point are 3, 2. Then to add them, we could just try adding the corresponding coordinates. When we do this, we get this point here. However, there's an issue with doing this. What if we drew our axes here instead? Then the coordinates of these 2 points are -2, 0, and 2, 2. And when we add them by adding the corresponding coordinates again, we get 0, 2. When we plot this point, we see that it is a different point than what we got before. In general, we see that as we move the axes around, while our starting points don't move, the result of adding the coordinates of the 2 points does move. The issue is, the position of the axes is completely arbitrary. Thus, it seems that this way of adding points won't work out. To fix this, many people just pick one set of axes and always use it. However, we're going to do something a little different. If the way we do algebra with points depends on our choice of axes, why don't we make this choice more explicit? Notice that our choice of axes singles out a single point in space, the origin of our coordinate system. Thus, we could try to find some geometric object that incorporates the origin. A simple object that does this would be the arrow going from the origin to a point. Thus, to represent points in space, we can just single out a single point to be our origin, and then we can represent any other point with arrows. The nice thing about this is that we don't need to worry about our axes anymore. In fact, we could just forget about points entirely and only use these arrows. Since we don't even care about points anymore, we could look at any arrows, not just arrows starting at the origin. We call these arrows vectors. It turns out that vectors are much more useful and easier to use than points, so we are going to be using vectors as our fundamental geometric object. Thus, to answer our initial question, the simplest geometric object that we will do algebra with is vectors, not points. One important thing to note is that there are actually many other ways to think about vectors, and we will cover several of them in the future. So while we are currently going to be talking about vectors as arrows, don't assume that that is all that vectors are. But for the time being, we will assume that vectors are just arrows. Now, some of you may be thinking, hey, I know about vectors. Do I really need to learn about vectors again? If this describes you, you can probably skip this first chapter and start at the chapter about multivectors. However, make sure you understand the following. You need to understand the interpretation of vectors as arrows, lists of numbers, and as elements of an abstract linear space. For each of these interpretations, you need to understand how to add vectors, multiply them by scalars, and find their length. In addition to all of this, you need to understand concepts like subspaces, linear dependence, span, and bases. I expect that a decent number of you have used vectors but haven't learned about these concepts. If that's the case, you could skip the next few videos and then jump back in partway through Chapter 1. I'll put exactly where you should jump depending on your knowledge in the description of this video. Anyway, for those who aren't going to be skipping anything, let's go back to talking about vectors. There are two main properties of a vector, its length and its orientation. The length of a vector is represented by a number. The length is also given other more fancy names as well, such as magnitude or norm. Changing the length is called scaling the vector. The orientation of a vector is the direction it is pointing. Changing the orientation of a vector is just rotating the vector. One important thing about vectors is that moving a vector around without scaling or rotating it does not make it a different vector. Vectors care only about their length and orientation, and do not care at all about their position. Before we move on, let's do an exercise to make sure you understand everything so far. Here are a bunch of vectors. Let's ask 3 questions. Which of these vectors have the same length? Which of these vectors have the same orientation? And finally, which of these vectors are equal? Please pause the video and answer these questions before continuing.
Yeah, I'm going to skip the
Let's
earlier
solve
stuff.
these questions in order.
Well, I don't know if I
First,
skipped all of them.
which of these vectors have the same length? We can see that there are three different lengths of vectors here. First, there are these small ones. Second, there are these that are a bit bigger. Finally, there are two here that are the biggest. Next, which of these vectors have the same orientation? First, there are these two vectors pointing to the right. There are also these two vectors pointing down and to the right. This one here pointing up and to the left is by itself. Now at this point, with the three remaining vectors, I will admit that I gave you something that is a bit tricky. All of these vectors are parallel, so it would seem that they all have the same orientation. However, notice that the vector on the bottom right is pointing down and to the left, whereas the other two are pointing up and to the right. Thus, these two vectors have the same orientation, and the vector on the bottom right does not share its orientation with any of the other vectors. Finally, which of these vectors are equal? This can be solved by looking back at the previous answers and seeing which vectors have the same length and orientation. If we do this, we see that only these two vectors are equal. Before we move on, I want to note that while I have been showing vectors in 2 dimensions, they are not limited to 2 dimensions. Here is a vector in 3-dimensional space. I have been showing vectors in 2 dimensions because vectors are easier to draw and think about in 2 dimensions. In fact, even though we can't comprehend it visually, we can also have vectors in higher dimensional spaces as well, which I'll explain in more detail later. We can also have vectors in 1-dimensional space as well, where they can only be on a line. This case isn't too interesting, but it's still an important thing to keep in mind. For now, I will continue to show vectors in 2-dimensional space, but keep in mind that unless I say otherwise, what I'm talking about works in any number of dimensions. Now, with numbers, we oftentimes use letters to describe them. This is useful because we can then start writing formulas with letters, and we don't have to worry about what specific numbers are being used. We can do the same thing with vectors. To distinguish between numbers and vectors, all vectors will have this little arrow above them. Instead of using this arrow, some people write the vector in a bold font. The bold font doesn't look too good in these videos, so I'll use the arrow. Anyway, using letters to represent vectors is useful for the same reason that it is useful for numbers. There is also the additional benefit that vectors are kind of hard to write in equations, so by changing to letters, the equations are easier to write and read. At this point, we can't do much with vectors without defining operations that we can do on these vectors. In the next few videos, we will discuss 3 of the basic operations that you can do with vectors. Finding the length of a vector, changing the length of a vector, or scaling, and adding 2 vectors together. Don't worry about how all of these operations work at the moment. I'll describe them in more detail later. You might notice a few things missing from this list of operations. I said earlier that the 2 main properties of a vector are its length and its orientation. The length is present here, but the orientation is not.
How you doing?
Talking about the orientation of a vector and how to rotate a vector
Just
is
finishing up
quite
this maths video.
complicated. We will get there eventually, but a lot of other material is required first. You might also notice that I mentioned that we can add vectors, but what about multiplying them? This is possible as well, but it is also more complicated than it might seem. For now, the 3 operations shown here are simple and you can do quite a bit with them, so we will explore them in the next few videos. After describing these operations, we'll go back to exploring how to use vectors to represent points in space. I would like to give a special shout out to Richard Penner for supporting me on Patreon. I don't plan on doing this big of a shout out in the future for supporters, but I thought Richard deserved this for being the first and currently only person to buy my highest tier.
Okay, we're not going to continue with that. But I think for the rest of the, while I go for breaks, I think it's good to go through the Sugma Lace, whatever it's called, Sug Black Moe or something. Through his 0 to 0 series, it's pretty. I haven't kept up with it, to be honest. So Let's see how many there are on the playlist. So I have got to... what did I get to? Yeah, definitely Bivector. Yeah, I think I got around here somewhere. I can't remember. When I remember doing operations with bivectors in 3D. So yeah. So QWERTY123 has asked, how long have you been learning graphics? Not too long. I wanted to try it because of Tokyo Spliff, but it looks really hard and maybe pointless for my career. I don't know about your career or what that means. Programming in general can get really complicated or really easy depending on what you end up doing. Let me just turn this down so we can play some music. And so it's not too difficult, but it can get very, 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 very difficult. Oh, okay, that's really loud for me. Let me, I'm just trying to adjust the audio levels. Just bear with me just a touch as I turn that down. So what I'd recommend is, one, are you already familiar with programming? And if you are, then programming graphics is just an application of applied mathematics at the end of the day. So is it too hard to learn? Is it worthless? Yeah, it depends, right? It really depends on your goals. If you want to try graphics out, I would say dive head first into it and see if you like it, honestly. I would start off with something a lot simpler than, like, say, a 3D game engine or whatever. I would start with, you know, can I make a game in... I don't know how familiar you are with programming, but let's just pretend that you know nothing about programming for now. Can you make a game that's just text-based, right? And did you enjoy that process? Because graphics builds on top of those skills that you start off with. And then you can, like, start learning graphics. And I know Tokyo Spliff has suggested learnopengl.com. And that's a fantastic resource. And I think if you just want to dive in and you're just ready to go, yeah, feel free. I also recommend that if you want to learn OpenGL. It's honestly, even if you end up learning Vulkan later on. So my advice to you, honestly, is try it. You know, don't agonize over it. If it becomes a frustrating waste of time, you can just say it wasn't for me. But you'll never know, honestly, if it's worth doing if you don't give it a shot. So I'd highly recommend just giving it a shot and see what happens. You know, the worst that can happen is you just go, meh, that was a bit mid. Anyway, back to what I was doing. The best that will happen is you'll end up with like cool graphics and maybe a game to play to boot. Who knows? So I really think you've got nothing to lose by just giving it a shot. In whatever way that may be. There's no real way. There's no, like, the best way to do this as well. I do have a roadmap on my Discord if you're interested for this type of thing. If you're interested in, like, 3D game development type stuff. It assumes that you know nothing. It's in the resources pinned message in my Discord. But again, you could just pick up learnopengl.com and just go through that from beginning to end. You know, it doesn't really matter, right? At the end of the day, it's all just practice. That's all it requires to get good at graphics programming. Like anything, right? Learning the violin can get really complicated, but, you know, if you don't start, you know, learning how to play Mary Had a Little Lamb or something, to see if you even enjoy it, then you will never know if it was worth your time, if it's going to be worth your time, if you don't give yourself a starting point, right? And like with violin, like, you might just be interested in, you know, playing a couple of songs, and that's it, right? Or you might want to be a concert level first violin, first chair violinist, right? And that's going to require like decades of practice. But that's like really intimidating. I would just say like either direction requires you to start, whichever end you're going down. Somewhere in between of like playing Mary Had a Little Lamb and being a concert concert level violinist. It all just requires just you to do it and practice. So yeah, give it a shot and see what you think. Right. This community is definitely into graphics, so if you wanted to stick around, ask questions about what to do next and stuff like that, yeah, please do. I mean, I ask the people in this community that's all the time about graphics, and I'm often getting corrections. So yeah, I'm just going to pack everything up. I've got like cutlery and stuff all over the place, so I'm just going to clean up, and then we'll get right back into our programming. So I'll be right back, gang. Hopefully that was useful. QWERTY123. Right. I want to clean up all this. Attract worms and flies. I might head to the loo as well. Yeah. Yeah, I'm just gonna head to the loo actually. Now I've stood up. Let me just do the professional streamer thing that I always do. Twitch chat, you're gonna see this for the first time. Look at this. Look at that. Professional graphics. Alright, yeah, I'll be right back. Alright, meow 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 meow. Meow meow. Meow meow. Alright, what are we doing? We have a problem to solve, rotation. With our particles. There's like a thousand things wrong with our programming. Sorry, our particles. So let's just see what we're up to. So I think the first thing we should do is reduce the size of the particle. It's a bit intense, right? Even if it was rotating with the camera, it's a bit nuts. If we were flying in this direction, it's a bit hard to see what on earth's going on. So let's start with that because it's kind of a. We could just increase reduce the size of the particle set, which is quite easy to do. Do I have the directional light on? Let me just look at the scene again. It just seems it's very dark. No, we do. Okay, yeah, we do. Just the debug geometry is tripping me up. Right. So we need to get the particle set. That is so max age is 3. I need like age in here. Thanks, said Quessy. I think that I'll try to create my first triangle. By the way, do you need university maths here? Because I dropped my university my first semester, but I was really good at maths in school. University level maths. It depends how deep you go with graphics. Graphics and I think machine learning, not using AI to code. I mean, like actually coding the actual models. Are the most intense when it comes to maths. But do you need university math? Like, let me show you my scene. Did I need university maths to understand this? No, not really. A lot of this was just like basic linear algebra and a tiny bit of calculus, if that, right? And that was used for the lighting, for the spotlight. A bit of trigonometry. And so if you want to create something like this, despite it looking a bit scuffed right now, you know, you should be fine, right? Like I'm lighting up this rock, for example. That was the most complicated maths thing. You learn maths as you go. Like that's what I would recommend to anyone who's learning graphics. Don't get too intimidated and not do anything, right? The last thing you want to do is count yourself out before you've even started. I would say literally just give it a shot, give it your all, and if it doesn't work out, fine. Learn the maths that you need to. I don't know if you're familiar with linear algebra, but you can always just learn the maths. There's books on it. It's not super difficult. You should be fine. Alright, so I'm just going to decrease the age of my thingy. Okay, so that's roughly where I want it, I think. Now I just need to make sure that I want to make it less. Let me think. Let's reduce the amount of particles as well. I don't think I need this many. So particle set 1 needs to be like 100. And this can be 100 and then 20k. It doesn't really matter. Yeah, if you were good at maths in school, you should be fine. Okay, 100 is a bit low. Interestingly, I feel like a lot of them. All right, let's increase the number. Just to keep increasing. Oh, we should start a timer again. Yeah. That feels enough for now anyway, outside of it not being sorted. So the particles aren't sorted. And I think if they were sorted it would look better and it'd look more impactful. Now you can see that there. It's kind of mostly sorted from this direction. But that's just, yeah, from here. See, it kind of looks okay. But anyway. Yeah, QWERTY. If you're still here, you'll have to post. You'll have to let us know how it goes when you make your first triangle. So what I'm going to do, actually, I'm just going to reduce this particle size. I don't really see the need to also do 20,000 for a particle effect. Yeah, because I think there's a... We could turn off this, it should be easy to see. Where's the green one? I have no idea. Oh, was that it? No. Ah, there it is. Yeah, so there's a green one. Yeah, it's doing the same thing. Cool. Let me just sort something out on my side. Okay, let's bring back Twitch chat open. Okay, cool. What are we doing? Trying to think. Let me just run the game again. I got completely distracted. Lost my train of thought. Are we trying to rotate things yet? Based on a camera position. So what we need to do, we need to rotate both, to be honest. So how do we know which way the camera's facing? So the direction vector is where we are. Let me look at my camera code. So we have a let's also move this back a bit as well. It's not the end of the world, but let's so it's negative when we go backwards. So let's just see where that goes. So it should be slightly separate from the actual duck right now. Yeah, okay, so it's a little... Okay, so that's actually tougher. Ah, okay, interesting. So the emitted... Interestingly enough... I wonder what we need to change. I think... I think yeah, okay, so I've called these something different in the past. So direction vector, right and up. Yeah, so it's the forward vector. I think if we somehow get the forward vector into here, we should actually be able to change the orientation of the particle effect, which is the first step. I think it's the forward vector that we need anyway. We'll find out. So it's going to be either forward, right, or up. And if we have the forward effect, we should hopefully be able to yeah, okay. I just think the up vector needs to be rotated with the position of the Yeah, so we just need the forward vector in here. We're just trying to figure out how to get it in. We could just keep adding stuff to the push constants, but I kind of I'm starting to run out of space. But I could just do that as a test. You know? Yeah, let's just... I'm going to do this as a test, right? It's not going to be the most efficient. So yeah, just bear with me while I kind of test this out. The other two I kind of like having in here, but we're just going to also just do a vec 4, which is it's actually quite big. Do we have some space for this? Hang on. So 8, 16. So we have 24, 28, 32. So we have 32 and then 36 and then 16 and 36. Let's just make sure we get this 100% correct, because this crashes the GPU if I don't get this wrong. Alright, 52. Alright, so this needs to be 52 now. Oh, what am I doing it editing in here for? Oh, whatever, it's too late now. No, it's not. It's not too late. Alright, okay. Alright. So I'm just going to send in the directional vector here. So this is the up vector. Oops. Vec 4 directional vec. So again, this is just because I don't really have a quick, easy way to test this. So we're not going to use up now. We're going to use this. And hopefully... Okay. And now we need to increase the... So particle render. Just curious, do you ever use AI to answer your questions when you generally don't know what to do, or do you search Google like we used to back in the day? The second one. I rely on Google. And then if I get really, really stuck, I just say skill issue. I need to get better. That's just me though. I've got like, sometimes you're seeing me doing development work right now at Andrea. But you know, I've got before, like hours before this, I was actually, the stream was, I would call quite boring, because all I was doing is reading this stuff. I was just going in here and being like, all right, let's just do some revision again. And I just try and make sure I do revision on various things. I actually did a bunch of particle revision, stuff I studied before. So I just do a bunch of study work. And, you know, I just keep developing my skills that way. Based, yeah, I think so. I'm not a big AI fan when it comes to learning. Same, I'm also building my C++ knowledge using CDM. Ah, brilliant. It's funny how many people have accidentally, because I kind of saw this and was like, oh, this could be used for what am I talking about? This could be used for programming, but it's funny how many other people have come to the same conclusion once they figured it out. So yeah. If I get generally stuck, it's just a big skill issue. Which is good, because it allows me to take control of the situation, right? You know, if I'm just like, I just want to get this working, I don't care how. That leads to like never understanding things properly, in my opinion. All right. Way to call me out. Will do. We'll follow your advice. I appreciate that, dude. Nah, I'm not going to criticize openly people who do their own thing. You know, at the end of the day, we're all just kind of hopefully doing this for fun. We're not taking it like giga seriously in the sense that, you know, we're all like worrying about this or that or anything like that. So for me, it's like, you know, I'm not going to be an elitist because I do things a particular way. You know, because not everyone here is trying to take programming to the as serious as possible, right? Not everyone's like trying to challenge themselves to become the best programmer they can possibly be. And I think all this can be added together, and just in the sense that so vec4s, this is a vec3s, okay. Because I have to remind myself of that sometimes, because I've got myself in trouble with other game developers in the past, where I've been like, why aren't you doing it the way I do it, you know, the proper way? And they're like, we don't care, we're just trying to get things done. I'm like, all right, fair enough, we're just doing it as a hobby. Oh, yes, there we go. Should go away now. Really? Oh, all the way around. I recently done a full Vulkan tutorial, created, rendered 3D, learned a lot. Now I'm trying to create a 2D render a game. Nice. It's pretty hard to remember everything. It's tough. It just takes practice though. I believe anyone can do it if I can do it. And I'm not really that good. I really don't think I'm that good at all, to be honest. But you know, you can absolutely crush it. So let's see. Oh, we need to change the size of this. I think. Oh, yes, we also need this here as well, I guess. Right, okay. How do you view the scenario, though? 1, get stuck. 2, search online, don't understand the things there. Ask AI. 4, spend several time understanding the AI solution. That's tough. Frustration is annoying, and it really sometimes gets in the way. I would say focus on what you can control. It's a bit weird to say that, but do you have control over what you understand? Serious question. If I read something in a book, do I have control over if I understand it or not? Or whatever, you know, online. I would say the answer is no. No, I don't have control over that. I might just be tired. Something might come up. I don't know what's, you know, whatever, you know, like so many different things can go wrong for me trying to understand something. Maybe there's some prerequisite knowledge. Maybe the book I'm reading or whatever article is poorly written, and I just don't know any better. So it's you know, maybe I'm trying to look up something and the solution it's trying to solve a slightly different problem, and I think it's the problem I'm trying to solve because I just don't have that knowledge. I can't work that out. You know, there's like so many different things that you don't have control over when you're trying to learn something. So for me, think of it like this, right? I like to worry about what I can control, which is how much time I can spend on a task. If you can do that, then it doesn't matter if you got stuck for 4 hours straight and you didn't even solve the problem, because you spent 4 hours on the problem. You can control that. And if you do that, you'll get better and better and better, in my opinion, from my experience at least. You know, so I would just say that. I would say like, well, the struggling going from step 1 to step 2, and then going back to step 1 again, and then step 2, you know, I don't personally ask AI because it kind of stops that. it takes away the thought, the thinking, right? The struggle of which you go through to understand it makes it you never forget it. If you really struggle to understand it anyway. Like, I've made silly mistakes in this engine, like, and I've gone, oh my goodness, right? I'll explain one, right? This is dead simple, right? I did a bunch of complicated maths, which I'm not going to go over, but I'll explain kind of like the idea. To do something called physically based rendering. If you've never heard of that before, I'm not going to explain it, but it's like how we kind of accurately represent light. So it's like physically based, right? Like physically based. Now, when I was actually working these out, where's the mistake that I made? I made a stupid mistake. Here, right? I did this. Now, when I load the game, assuming that hang on, this might not work because I'm in the middle of something. Actually, it definitely won't work. Don't crash. Okay. Let me just do one quick change, and I'll come back to this because I need to. The pipeline size of the buffer needs to. Oh no, it's okay. Okay, I've automated it, so maybe it shouldn't break. We'll see. Fingers crossed. All right. Ignore this like horrible particle effect. But you can see that everything's really dark. The light looks really dull, and when you get really close to it, it looks like shiny and poopy color. I had to turn up the intensity loads, and I just didn't understand this. Like, why is it going so dark? I've done everything else correct as far as I'm aware, and it turns out I was multiplying when I should have been adding together. Right? That took ages to figure out. But I didn't have control over the fact that when I figured this out, you know? Like, when it clicked in my head, I was like, oh, I'm an idiot, right? It's an addition and not a multiplication here. And you can see the difference, right, if I load the game. If I turn off that, it now looks normal again. And, the two lights that I'm using are actually lighting up the things properly, as you can see. I'm trying to not crash into a rock as it disappears as soon as I touch it. But I don't have control of when I would be able to figure that out. So interesting. I was just messing around with the particle effects right now. So that's why I focus on the hours. I see of you, if you invest hours infinitely, the knowledge will grow regardless. Yeah, exactly. I've made a video on this. I'm not going to try and shill it or anything, but how to become an expert at programming is on my channel. And the second half of the video is literally me explaining like what my process is for like worrying about what I can control. And I have like a whole silly ranking system. I time myself, as you can see here. This is what this is about. And then I add up all the things together, all that type of stuff, right? Why am I getting what is this about? Achieved. I don't know what that is. Yeah, I'm on Twitch as well. I'm kind of new to this Twitch thing. I've been on YouTube for a while though. Anyway, right. There you go. Yeah. Yeah, seen that. Been a subscriber since. Yeah. But there you go. That's why I focus on the time, because I do have control over that. I think of it like this. Let's just say a problem took you 2 weeks to solve. That problem was going to take 2 weeks regardless. No matter what you would do, it would have taken 2 weeks. So might as well just get the 2 weeks done as fast as possible. But yeah, there you go. That's what I do that for. And that's why I say, when I said like it's a skill issue, it's because, I can say that to myself, right? Alright, I'm gonna try like a few different like vectors here. Let's try the. Let's just check. Did I modify the right thing? If I go to. Right, so I'm gonna just leave that for now. Okay. That's a vec 4. Okay, so we're going to do up. We're going to see which one is useful for us. I think I'm going to do forward next. See if that changes things. Right, so the right position. Oh no, which vector we did use? We're replacing the forward vector. Oh, I replaced the wrong vector. Oh my god, I'm such an idiot. Yeah, I got this wrong. I replaced the off vector, and I should have replaced the forward vector originally. So let's go back. This needs to be here. It's not the up vector. It's this one that needs to be changed. .xyz. Let's see. Let's just check our music. Yep. Oh. Interesting. What? So when we update the particles, what are we doing? Why does that mess things up? That should be the particle emitter, not the... Anyway, let's try a different vector then. What's wrong with that? So let's just try the different vectors, I guess. There's no real reason not to try it. So we definitely use this for... What do we use this for? Hang on. I might be messing things... Breaking things. Ah, right. Yeah, I am breaking things. Okay. Right. That makes sense. Okay. Let's throw this in here. So if the directional vector is that, then we need another vector to put in the push constants, which I'll do. Let's just do test vector. I don't really know when or why we're going to use this, you know. If we're going to keep using it, not why. Test vector, throw this into... Hey Heisenberg, how you doing, dude? Good to see you again. Just so you know, the notifications are... I'm on OBS again, so the notifications don't quite work anymore for YouTube Ruby things. Sadly. Yes, so test vector, this needs to go into our... Like this. Like this. Right, cool. I'm good, yeah. Review fun is gone, yeah. I know, it's poopy, but yeah, I'm good. I'm not too tired. I'm not too... I was very tired yesterday, so I did a very short stream. Just chilling, trying to get stuff working, so I'm going to use the up vector here. Anyways, I spent all my rubies on your channel. Oh, thank you. I just wanted to, yeah. I mean, if someone spends rubies on my channel, I'll always make a fuss. But so for those on Twitch who are like, what the hell are you talking about? On YouTube, there's this thing called rubies that you can. It's like bits, effectively. You know, if you were to throw some bits my way, it would be the same as rubies. I know not everyone's. It's been only on vertical, you know, like on your vertical streams, kind of like TikTok, but yeah. Anyway, so that's it. It's not that exciting. But it does support the stream, so it's always nice when people do it. Alright, so let's get our directional vector out of here and put this in. So we want to put the forward vector back. Right, let's see. Can you show me your space? Can you show me your specs again, please? Yep, I can indeed. I still haven't fixed the typos in it, so you're gonna have to put up with that. But yeah, there you go. All right, so is it just me, or is it legit facing the right way every now and again? If I reverse this in the shader, directional, right? Negative. No, okay. Yeah, no, it would work if it went upside down. How do I spin this around? Alright, let's just try the right vector then. Holy shit, said Heisenberg. That's what you're able to do. YouTube plus Switch plus programming tabs. Nice, man. Yeah, got it running. I'm trying to get the thruster effect to work. It's not rotating with the camera. Let me just change the music. Let's listen to Alone Fire. Yep, so there we go. I barely know how Twitch works, to be honest, so can I see myself here? How do I see myself live? There we go. Okay, there we go. Oh, there we go. Look, that's for the YouTube chat, and this is for the what is it called? The there we go. Look at that. So you can both see each other. Make sure you play nice for both stream types. It's my first day. To be honest, I don't use Switch. No problem. That's all. If you want to be on YouTube, that's chill beans by me. It's all good in the hood. Okay. What are we doing? All right, so we want to do the right vector as well. I feel like we need both, but I'm not going to try that until we've tried them all individually. So I might even get rid of the transparency because it kind of looks really, really bad, to be honest. Until I start tackling transparent, I don't know. No, I'm worrying about nothing. So let's use our right vector and see how that goes. And if I go into the computer shader now, then... But I think we might need up and right. I think we might need all on. If you know what I mean, right? So this is now up. So we need the directional float. There we go. Multiply that together. And yeah, that's about right. Okay, let's just see how that leaves us. Make normal videos as well. Your last video kind of got viral. Yeah, I guess it did. It was surprising. Honestly, very, very surprising. That video did as well as it did. The last video, so for anyone who's on Twitch, I made a video called How to Become an Expert at Programming. And it did very well. So it kind of went viral-ish. You see that all the pixels were ordered then, which is quite cool. No, I don't. Yeah, okay. I really don't think it's doing anything. I think I need all the vectors in here. So let's bring them all in. I think we have enough space. So if I add, man, this looks so good. Thank you. I'm glad you think so. So plus 16. Right, so we have 84. So I'm just going to increase the size of our push constant, send in all our camera coordinates and see how that plays with our setup. We shall see. If it's always facing away from the camera, that's actually massive. Wrong, we don't want to touch this. So I want to go into... yeah, I'm kind of sick of not making progress, I'm not going to lie. So it's been nice making progress today. So directional, up. It's been a slow... there's still a long way to go, I'm not going to lie. But we're getting there. Right, so we send in these three vectors. And it's 84 size, which is still fine. Next video title and thumbnail. How to become the top 1% in programming. And that'll go viral as well. Yeah, can you imagine? Just keep making the same video over and over again. That'd be funny. It's funny, I actually made that video for people who have been watching along with the live streams. Like, that's why I was surprised it did well. I was like, alright, so occasionally people ask me like how to learn Vulkan or whatever. And I was like, right, I'm sick of getting the same question kind of thing. When it comes to like how to learn stuff, so I was like, alright, let's just make a quick video for these people who are interested in learning graphics and getting really good at programming. And that was it basically. I was like, alright, I've got to make my case a little bit, so I'll spend a bit of time doing a research. And yeah. And it blew up. I actually struggled to make that video. It was kind of like I didn't want to make forward. Oops, have I put forward in twice? Yes, I have. I meant to say right. Where's the right vector? Yeah, this is... Okay, so this should be this, and this should be right. The main key is the title and the thumbnail. It should be kind of catchy, you know, like what would catch the attention of people. Yeah, it's for me, I made that thumbnail because I feel like it's true. Like, I am aware that, you know, the catchier the thumbnail, sometimes the better the video does. For me, it's like I want to tell you a story. That's my goal. And yeah, that's all I wanted to do. I just wanted to make sure that, you know, there's been so much confusion on how to like get good at programming for newer people anyway, that I just wanted to be like, all right, let's set the record straight. And then the thumbnail and the title are just a ways to test 1 and test 2. I just like what can I distill the message of the video down to one thing. And yeah, I don't think most people make it. I don't think most people become experts in programming. I think it's just facts. So that's why the thumbnail had you're likely not going to make it, because most people won't. Most people don't become experts, and most people don't even realize like how good experts are. That's the other thing that I think I maybe should have touched on. It's like when you meet an expert at programming, you know it's very different. Yeah. Yeah, thanks, dude. Thanks, Heisenberg. I mean, I don't feel like I've made it, to be honest. It's funny, I say that in the video, like I've made it. But I think I hopefully made out, like, I think I said it pretty quickly in the video that I don't feel qualified to make this video. So I made it anyway, because I was, like, literally... I wanted to help you guys, you know, like, who are interested in programming, who will watch me live. More than anything, right? That was my big thing. I literally made it for I'll admit it. I made it literally for Forsaken or Mabdo in the chat. That's who I made it for. That's who I had in mind when I was making that video. And I thought maybe Emmanuel and maybe a couple of others would have liked it. And that's it. That's all I cared about reaching. And they seemed to like it, so that was it. The fact that other people liked it was a surprise, honestly. Who knows why Heisenberg's doing it? I'm a noob currently, but I'll find a way. I'm working on myself. Let's see how it goes. Yeah. Hi Zenny. Zenny. Hey, how you doing? I used OK underscore cut. So for those who are wondering, Dimitri's message just get translated to English. So I'll just read this out loud. Hey, how are you doing? I used OK underscore color yesterday. I googled. Oh, I see. Okay, yeah, you googled. Yeah. Okay, use the different color space, not OK underscore color. I understand. It's easy in C++. It produces a nice gradient. Yeah. But the color just doesn't match the test demo. I figured I had to debug it. Yeah. Yeah, it's yeah, I do like. I don't mind that color. That color space for me is. It's definitely more vibrant in, I think, the blues. I can't remember. It's like blues and yellows. It's really vibrant in the CLH. Yeah. I can't remember. It's really vibrant in one area. I like more of a balanced one, so I've gone with just a standard sRGB color space. That's kind of cool though. You're experimenting with different things. Right. Anyway, let's continue with our compute shader. I hope Twitch chat is enjoying these streams. I hope you're not feeling left out. Feel free to send a message or something like that. As long as you guys are chilling. Don't worry, I have you guys open as well if you do want to say something. True, I couldn't create. We do be chilling. That's fantastic. Okay, cool. I'm glad. I just wanted to make sure you're not being neglected if you did want to talk. That's fantastic. I couldn't create a... So Dimitri has said I couldn't create a const val in pure C++ because of how power... Yeah, that makes sense. But I made a static table very easily. That's a very good way of doing it. That's a very good way of doing it. Yes, that color conversion. Nice little fast lookup and stuff. Anyway, right. I think we're done. Let's see. Let's make sure everything's good so we don't crash the GPU. Right. Let's see. We might get a compilation error, but I don't think so. Right, error. We do have this, which is kind of fine, because that's kind of the point. So I should have named these instead of just test vector, but as far as I'm aware, yeah, I should have named these, dude. Up, maybe? I think right's last, yeah. Dimitri is a GTA 4, in GTA 4. Yeah. Is this name actually Dimitri? I do like GTA 4. I just haven't played it. I just never got into them. The GTA franchise. But it's definitely my most... I do like the aesthetics of GTA 4. GTA 4, like, looks... It still holds up to this day. Yeah, okay, so right is set. Yeah, okay. Up is... Yeah, okay. Let's just see what that does. I don't know what this is going to do. Is it rotating with the camera at all? It is rotating. It's just really confusing. Is it always facing away, the camera? Can I... Okay, so that's the correct way. Why is it facing down? So Dimitri has said, just make sure the music's still playing. Let's play a different track. It's a big Slow Moon. I do like Slow Moon. Bit of a melancholy soundtrack from the 16-bit era. Let me just check something in. Okay, we're chilling. So Dimitri has said GTA pretends that Russians are cool when in life there is suffering and then death. I can see why you're saying that, dude. Yeah, it's tough. It's tough out there in Russia for, you know, considering the circumstance, which we won't get into. Yeah, it's you know, it's not good for anyone. I'll put it that way. And I know, like it's basically out of people's hands how things go in the world when it comes to that conflict, which I'm referencing. You know, so I just wish everyone the best who's in that situation. I know it's maybe I don't know how to say it any other way, but yeah. I wonder if I'm doing this wrong. I wonder if what I need to do is actually rotate the particle set itself rather than the particle emitters. You know? Dimitri said, yes, not much has changed. Where what you're saying is precisely the reason why nothing is happening. Yeah, it's tough. Well, as long as you can enjoy what you have. I know it's easy for me to say. I'm just glad you're here, dude. You're a cool guy, Dimitri. Anyway. Let me think. Yeah, I'm going to try and rotating the emitters themselves, the particle set. So when we want to rotate that, we have what we could do. So we have the transformation matrix, obviously, which is easy to do. But what are we rotating? We could pass in the cameras, like we could build the view matrix up. I think that might be a go, actually. I think what I'm going to do actually is, if I'm going to do the view matrix, I might as well just pass it in. Yeah, so I'm going to try and build up a rotate the emitters. I don't know if that's correct, so I'm kind of exploring as I go. So obviously the actual particle pushing data was wrong, but maybe I can camera view, yeah. So if I get the camera view, and paste that in, oops. And what we're going to do is just send in the camera view, which I do believe we have. I don't think I need the projection matrix, but I do believe the positional matrix is the camera. And I wonder if we basically make the particle emitter where the camera is. I don't know. This is likely going to break what we currently have, so I'm prepared to have like this nuke. So yeah, so what we're going to do is, so a 4x4x4x4 is the view camera, and I wonder if I need to know the maths. This is so maths based. Yeah, I'm not very confident with the maths right now. That's why I'm just experimenting. Let me think about the maths though. So we have a transformation matrix which has no rotation in it. Yeah, I'm gonna make. Let me think. So the directional matrix comes from, yeah, okay, so this all just comes from there. Okay, so what I'm going to do is not do anything. Yeah, okay, immediately we won't do anything. So we have the internal camera. We just need the rotation as far as I'm aware. So this is the view. And for now, do I have, oops, this is a map 4. Yeah, okay, so this is just going to match the compute shader. And then we have the rotation, I think, applied in the view matrix. I mean, we'll see. I don't know if we have both, right? Let me, I just need to make sure this doesn't crash the GPU, so a very quick change. I just need to make this a map 4. We're not going to use it right now. And I just want to change all this up. Wait, what am I doing? I'm being dumb. Yeah, I'm being stupid. If we're rotating the particle set, not the particles themselves, we don't put it in this at all. That was stupid. But what we do is we take in the data. So if we have, okay, so copy, yeah. We're going to make a mat4 based on this transform, and I hope we can just do this, right? That's the idea. So hopefully we have the translation data, sorry, the rotation data as well, because we need both. And I'm not sure if there's a particle emitter or what that needs to be done for this, but we'll find out. Let's go into game. Yeah, okay, so this may break everything, but I'm kind of curious what this ends up doing. Oh. Okay, so it is... Weird. No, that was completely wrong. I think we're multiplying by too many vectors here. Oh, no. Oh, right, okay. We might have had it before. But the way we're doing the billboards might be bad. Billboards. Okay, so what am I talking about? Oh man. The particles are really close to the screen, which is dangerous for what we're doing right now. Or dangerous. It's not going to break anything. But what I mean is, where is my notes? Graphics theory, billboards. All right. We're doing this. We're doing A, not B, right? So when the billboards are really close to the camera and we rotate, they don't look right, right? And it's fine when the particles are really like small and far away, or like traveling at a speed. But if they're constantly in the camera's view, then this starts to break down because we're just parallel to the XY plane. Right, I think we need to improve our billboard rendering. We can't do what we've been doing. I think if we're trying to recreate this effect, because it breaks down on the individual particle level. It's hard to show, but if I get rid of the silliness that I was doing before, yeah, let's just press Control Z actually, so I don't. Oops, that's a bit much. All right. And if I get rid of this, actually it's fine now. It doesn't really matter. But if I you know, that's fine, but like the particles look weird when we get to the outer side. And I'm just wondering, no, it's fine. I just want to try this. Let me just try something like side tangent, side quest. I just want to see like how better it looks without the texture. So what I'm going to do is just change this to (1.f) 0.f 1.f magenta style, because there's none of that blending. So this is just a side quest. I'm just kind of curious, like how much better. Yes, it breaks this as well. Why is it doing that? Why it's not shading the whole quad? Oh, that's why. Yeah, let me just get rid of all this. Yeah, sorry about that. I was confused why it wasn't rectangles. Squares, sorry. Honestly, it actually looks worse. I mean, maybe if we moved it to a different place. Yeah, I was just kind of curious. It just completely blocks the view of the camera. You can see. Okay. So it is super confusing actually. Unless I have the transparency on, it's hard to see which way this is actually facing. Like that's what it should be the whole time, no matter which way I rotate. Right. Okay. Why is it just emitting big squares? Because I turned off everything when it comes to the actual texturing. So I was just kind of curious if it actually looked better. It actually looks way worse. Well, I don't know. Maybe subjectively people might say that looks better, but I think that looks... You can't see what's going on versus this, right? Yes, the transparency is not ordered. But, you know... It would be nice to be able to see the bloody character, you know, as it's flying around. Yes, there are like transparencies that are not working. I really need to work that out. I need to know something like, how do you order transparencies? Thank you for rejoining, bot, and also just posting a poop emoji in the YouTube chat. Make sure everything's good. Okay. Hello, Mabdo. How you doing, dude? Good to see you again in the YouTube chatteroony. Let me just think for a minute. I'm just gonna pause and just collect my thoughts briefly. So we have this directional problem, which means that it's not always facing the camera. The billboards are good to see you back. Thank you on YouTube. Yes, I sneaked on Twitch yesterday, so this is I'm on both. Ta-da! And YouTube. Ta-da! Yeah, thanks for liking the stream, guys. I just noticed that. So, at the moment... let me think. Yeah, I can't play copyrighted music on YouTube, otherwise it just completely nukes my nukes everything. Let me think. All right. Yeah, thanks for all the follows on Twitch as well. Very much appreciate you. Sorry, I'm a bit quieter now because I'm trying to piece together like what do I actually need to know to do this rotation properly. I'm thinking. So I have this compute shader, right? Sorry, I have this vertex shader that does the billboards, right? And that always faces the camera. Now I'm kind of wondering, does the velocity of the camera need to... Sorry, do I need to do the same thing? Where is the billboards? Here, right. So we send in the this stuff, and this is just this just does this, by the way. I thought it was to do with the fact that we're not perpendicular to the normal of the camera versus we're just projecting onto the XY plane of the camera. The billboards are fine as far as I'm aware, actually. Now, if I want to take the particles and I want to make sure they're always facing the camera as well, do I also then need to do this positional change based on the XY position of the actual individual? If you know what I mean. Right, so individual particles are rendered like this. The vertices are transformed like this. But I wonder if the emitted direction, if that makes sense, needs to also have the same idea where we multiply. We basically do this, right? I don't know. Maybe. So that would be the right and up vectors. So that's what I'm thinking. I'm thinking about doing that, but let me just think through the maths a bit. So if we have the emitters going in one direction, that means the... Let me look at the maths in my compute shader. So we are basically doing the simplest thing ever. We are adding the old position to the new position times by delta times by 10, just so it actually moves. Otherwise it'd be really slow. Might be worth increasing the speed just for this demo. Alright, so we multiply these two together, we add them to the old position. We then need to... Oh man, if I just knew the maths, it would be so much easier. Does the velocity need to be the XY component of the velocity of the camera multiplied by... Let me see. This is just one maths formula. That's all I need to know. There's just this. That's the only thing I know yet. Position plus. But this is completely different. This is for the vertices themselves, not the. Alright, I can try it, but the XY position plus... Okay, I got an idea. Let's just see individually what these bloody things do, right? So what I mean by that is if I just don't move the camera at all, and I fly in this direction. So that is at a right angle from the camera, right? So let's just change these values around, right? So if I go 0, I don't know what to do, to be honest. So let's just do a like this and see what that does, right? So we're just going to be very careful here and just see if what is rotating what, right? Okay, I just want to see which direction that is in. Oh yeah, okay, so that is interesting. I got an idea as well. Let's also let's remove the randomness. I think that's going to be the biggest giveaway, right? If we remove the randomness and like this, right? So we have 3 vectors. I think we're just going to get a stream of particles going from one direction. Yeah, okay, so that's the pure like orthogonal angle, if that makes sense, right? And so what we need is this always needs to be facing the camera. The center line. All right, so that's actually quite good to know. And when I actually move, give me a minute. All right, so that's what it is at the moment. And if I was to say, can I do this? I don't actually know. So up didn't change anything. Yeah, we can. Oh, I didn't save. Hang on. So we're just going to have to go backwards and forwards between this and just see what. Right, okay, so the up. Right, okay, that's good to know. That goes there. Yeah. Okay, this is how we're gonna reverse engineer this. One step at a time. We're gonna get this. And then we can figure out what we need to multiply by and what the vectors need to be and all that kind of stuff. Okay, so that goes from here to there. Interestingly enough, I expected things to be completely different, to be honest, but there we are. In fact, what we can do is, yeah, okay, so that's the wrong way. That's what I wanted to see, right? That was my first. So right needs to be this way. What I'm going to do actually is I'm going to zero these out, and because I haven't moved the camera at all, we should be seeing it from a particular orthogonal. Yeah, it should be like right, left, up, down, right? Okay, so that's exactly what we need it to be. As far as I'm aware, anyway. Yeah, okay, so that is the ideal setup when we haven't moved the camera at all. And if I was to put this into render doc, does right always need to be this then? I think it does. I think right always needs to be the same. But the up and forward vectors need to change. Right, because if I was to do like a 001 or something, like what does that do? Okay, it's a bit not enough, but I think it's moved to the left a bit. All right, if I do this is probably easier. Yeah, okay, so it's moved over to the side. So as we do this, the forward vector needs to change. Okay. That makes sense. Okay, so we need the forward vector for that. I don't know about the rest though. Yeah, so we need 1, 2. We just need 2 vectors. Alright. So as far as I'm aware, anyway, we can just recreate what we did before. But this time, instead of having a... forward... I'm just going to see how this affects things, right? If we keep the right vector... What I want to see is nothing change, right? When we add this in. when we have a camera that doesn't move. Right? So that's what we're going to work out next. We're going to see if, when we go into a particle renderer, and we pass in the, oh yeah, we don't have an argument right now. Oh, I mean, we could just make the, so when I go into the particle renderer, what's the up vector then? It's this, which is chill beans. So if we haven't, oh, is this modified? Oh, camera view. That's what I called it. Actually, this is m dots 0 1, right? Yep. All right. This is 1 1. Oh. Oh, yes, it doesn't know what this is because I haven't specified. Oh, and I think this needs to be, yep, this. Cool. Then we can remove this. Oops, what was that? 2 1. Yep. 2 1. Right. So we should not get any difference at all if we haven't moved the camera, right? If we have, then this is not what we want. Again, the two things that shouldn't change are the direction at which we're facing. But we'll see. Cool, 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 cool. Now, what ends up happening if I... So this doesn't do jack. Which is... Oh, I haven't even modified it in the... Okay, don't get too excited. I hadn't actually finished. Oh, I'm surprised that worked, actually. Jeez. Do double forward. All right. Right, let's try again. Oh, hang on. That's just not going to work. This needs to be 1. This is very fragile. I could crash the GPU, which I don't know what Twitch is going to do if I crash. Okay, so it's... Why has it done that? So it is changing direction once I rotate. But it isn't when I'm doing this. Okay, so I've got the wrong vector. This is not forward, this is right then. So that should be there. Let's put this back. I mean, I'm going to change it to right in a minute, I think. I had this earlier that you tried rotating the emitters, but first I didn't catch why it didn't end up working. I'd expected passing the emitter. I have expected passing the emitter space transformed with a relative emitter velocity to be straightforward. To be a straightforward way to do this. Straightforward way for this. Yeah, which way are we facing here? Why is it doing that? I mean, it's just kind of cool, but it's facing up now the whole time. All right. We're making progress, though, I think, right? I'd have experience passing the emitter world space transform with a relative emitter velocity to be a straight. Is that what we're doing? Let me think. I'm trying to use camera space, honestly, to get this to work. Yeah, I didn't try running. Like, you specify the velocity to be always forward from the emitter and rotate the emitter to face the camera. That's what I'm trying to do, yeah. But maybe I'm getting this wrong. Yeah, the actual transformation of the emitter is happening somewhere else. It's happening here. Here. In the particle set code, per particle set. So when the maths gets applied to the individual particles, it's happening here. So that's what I'm trying to figure out. Like, how do I... But yeah, maybe... Hello, Forsaken. Thank you for joining us on the Twitch side. How you doing, dude? So I'm just trying to... let me try to what Trunks has said, or Siri Trunks. I heard earlier that you tried rotating the emitters first, but I didn't catch why that didn't end up working. Yeah, so... there's a bunch of spaces happening here, and it's kind of tricky. Yeah, let me take a step back. Maybe I'll try. I'm going to try and evaluate. Let's change the song real quick. I need like a new track. Oh, what's Twitch telling me? Achievement completed, new day, new stream. Sure. I don't know what that means. Sorry, let me yeah, you're right. If I rotate, so I have 3 spaces that I'm working with right now. I have the camera space, I have the individual particles themselves. Which are in like their local space based on, you know, whatever logic I've used. And then I rotate those particles based on the position of the camera into, you know, I don't know, camera multiplied by... But yeah, you could be right. If I just make a... So what I did is I just used the camera's view. Hang on. Yeah, I think you might be right, actually, now I think about it. Because it doesn't really matter the final state of this if the emitters... oh, there's another Forsaken. Okay, there's 2 Forsakens. I have YouTube chat and Twitch chat open, and there's someone who also goes by Forsaken. That's who I was talking to, the Twitch chat, Forsaken. Oh, it is you. Okay. All right. Yes, let's leave this alone then. Let's leave this alone. Let's leave this alone. And if we just rotate, yeah, if we try and rotate this, yeah, okay. Yeah, I think you might be right. I think you might be right there, Sir Trunks. Sri Trunks, not Trunks. Let me yeah, because I'm at least getting the position right? And if I just build up the rotation matrix as well, based on the camera's rotation, then it should be, yeah, okay. We do have the camera's view matrix here, which is yeah, I can actually send in the rotation matrix of the camera, right, and build up a make rotate. Let's see. Make underscore rotate. Oh, DLM's rotate make. What does it need? It needs both, which I don't want to use. Okay, let me just look into this real quick. I think we have a. Do we have a quaternion? I think we just need to make this into a quaternion. Yeah. If I just yeah. Okay, so I'm just going to take the camera's rotation quaternion. How do you print hello world? Depends what language you're asking. I can let you know if you tell me the language. But it's a great place to start. Getting the computer to do anything at all. Okay, so I have a rotation here, which is a quaternion. We pass that in over, and then we make a rotation matrix with a translation matrix, multiply them together, and see what we end up with. That's what I'm going to do. That will be in camera space. I hope that gets us the right direction, at the very least. So what I'm going to do then is, I don't think we use this. If we do, I'm going to get rid of it anyway. I think unused variables are fine. In fact, I'll just clean up. Yeah, okay, so yeah, okay. Let's get rid of this so we don't have any weird breaks. And we definitely don't have forward. Yeah, okay, so now we're going to, yeah, okay. I'm going to get our camera's quaternion. Which for some reason are called visors. Or visors, yeah. Camera's rotation. Camera rot. Echo hello world. Yep, that's a valid approach. Oh, how do I do this? We need to go into the GLTF loader because that's where I do this properly. And we take the quaternion logic. I just forgot the function call. We're just gonna turn a quaternion into a rotation matrix. There's a function call for it. I think it's near the top actually. Yeah. There it is. Okay, so GLM quant map 4. Okay, let's take that out. It's not a visor. Hang on. Why are you complaining? Matte floor. Oh, hang on. Is it S again? I think it is. Yep. Okay, cool. If we go back to game, that should stop moaning now. Yep. Okay. And then we step into here, and we're gonna go into here. Then we rotate everything round, so we have a GLM's quant map 4. Right, pass that in, and then we basically multiply these two together, and obviously the quaternion mot thingamajiggy. So this is and this is GLM's mat for mul. Put that there, comma. As far as I'm aware, alright, so that's going to bring in the camera rotation matrix when we've pulled everything out of this computation shader. So nothing weird's going to happen. Right, so let's have a look. Oh. Now we're in the wrong space, sadly. Oh dear. Ah, no. Maybe we don't translate. Order of multiple. Yeah, maybe. Let's just check. There's a couple of things that could go wrong there. We might not want to translate. No, we do need to translate. Let's just check I got that right, because I do have the code up here again. So we're looking at this here. Translation second. Oh yeah, you're right. I got it wrong way around. Let's fix that. Yeah. Okay. Interesting. Why is it doing this? Oh, this is so confusing. It's broken the billboards. I got a book, says Mabdo, called Essentials of Computer Architecture. It's quite fascinating how little of the fundamentals I know. Well, that's good that you're learning a lot. Essentials of Computer Architecture. No, I haven't heard of that book actually. Ugh. Hey, how are you? Sorry, I had started preparing food. It's Garib. Oh, okay. Hi, Garib. On an alt account. Yeah, not bad. I'm doing good. I'm just trying to... I'm just confused with my maths. When I have days like this, I feel like I need to go into a cave and code, do maths for 6 months and then come back to this properly. So Mabdo has said it's a book called Computer Architecture is a book that teaches low-level stuff from the point of view of a programmer. Nice. Okay, cool. So let's look at let's see. If I look at my my vertex shader for this particular thing. What I'm going to do actually is just get rid of these for now, just to see how this transformation looks. Sorry for broken grammar. Not at all. Sometimes I will read messages wrong, by the way. I am dyslexic, so just be warned. Sometimes the so if I am reading something wrong, you know, you can always but no, your grammar is completely understandable. No, I just think this is poor. No, this is not working. Hopefully your food is your food goes well and you make some nice yummy food. Wait, what are you making, by the way? It doesn't dive into the, so Mabdo has said it doesn't dive into hardware, instead it's how benefits okay. That's actually quite cool. Essentials of computer architecture, hey, nice. Yeah, so right, so this breaks the billboards completely. When I translate, let's think. I'm so confused, honestly. Yeah, let me look at the. Let's take a step back. Let's take a step back. No, I don't think anything to do with the particle rotation is going to make any difference, to be honest. Because it's not really being emitted from that direction. It's being just the maths arbitrarily being done, right? As far as I'm aware, anyway. Preparing pasta. Nice, I love pasta. And after dinner, And after my dinner, I just played CS2. Well, hopefully your games went well. Yeah, I'm a bit confused here. Let me think. I started coding after a strong... that's the way to do it. Get your caffeine in. Do some coding. I drink tea, unsurprisingly. As my accent probably gives me away as someone from the UK. Sometimes I'll have a cheeky cup of tea if I'm getting really tired. Alright. Are you passing... Are the computes... Are you computing the emitter's velocity? I don't think so. What I'm doing arbitrarily is just multiplying some stuff together. So, sorry, I keep opening up the shaders in the thing. I'm trying to break the habit of using Visual Studios. So this is the mass that's doing the... it's literally just taking in a buffer and it's doing something with that buffer, right? That's literally it. The emitter has no, like... It doesn't know what the emitter even is. We just know that the starting position... Let me like try and clear this up. That was super confusing. So we do have an emitter here, which is just we have a particle set. So it does. We do have like transformations here and stuff like that. So maybe what you're saying is I should translate the emitter transformation here, because I can do that. By this vector equals the vector. Okay, let me try that. Visual Studio shader language supports. Yeah, it's super annoying. The emitter knows where it is by subtracting where it isn't. Yeah, exactly. It knows exactly where it is from exactly where it isn't. I've never heard anyone reference that meme before. It's such a good meme. So if I multiply the velocity by the position like this, I will get a new position multiplied by the whatever the velocity, oops, right? Yeah. Is that, yeah, I think that's what you're getting at. All right, where was I up to with this? Let's go back. So yeah, we are still doing that. Okay. You might not be looking to swap, but I've been using slang. It's really good tooling. Haven't tried it too much though. I think most people have tried to move you to slang. You're not the first one. I'm hoping. So Ratchet is hooking up his custom allocator with Tracy. Nice. I actually. Am I not multiplying this the right way around? Yeah, probably. It's a vec. Oh, it's a vec. Bloody. It's a vec. Change this to a vec 4. Make this homogeneous. Wrong way around. That was definitely the wrong way around now I think about it. There we go. Why are you complaining? Oh, did I not save? Whatever. I'm just going to make this vec 4. And we're going to assign this up to a vec 3. Yeah, let's make these all vec 4s, right? I'm not going to just deal with this silliness. Just going to make them homogeneous, obviously, so they actually work. All right, cool. Vec 4s. Now they're all vec 4s. Now we don't have to deal with this silliness. All right. Can I do a multiply equals actually on this? I don't know if this makes any sense. I've never actually tried that. What does that do? Yeah, everyone hates GLSL. Yeah, 100%. Slang is kind of unstable. They have a lot of compilation bugs. They also NVIDIA's pet project, so a lot of AI stuff. Interesting. You should probably want the W component on the left to be 0. Oh, sorry. Really? Oh yeah, with the of course, you're right. Yeah, because I'm adding them. Oh, this is so confusing. Yeah, if I was multiplying, if I was doing some like dot product stuff or whatever. Okay, you're completely right. If I'm adding them, and then Yeah, the reason I don't really have a preference, to be honest, when it comes to languages, so I just stick with what I kind of know. Alright, so now when we multiply by a shader, it's not going to go crazy. Obviously, that doesn't fix the other things. Oh, man. 63. Oh, I'm an idiot. Hi, Bart. Thank you for the lovely stars. And a bug gets fixed every week or so, but it's still annoying. You can't get it from the SDK, basically. GLSL is mid, but it's stable. What do you use, by the way, Ratchet, in the YouTube chat? I thought you used slang. But I could be completely wrong with that. Okay, so 98. 96, sorry. Okay, so that was that. You can do that. Okay. Is there anything else that's used? You've been using GLSL. Got you. HLSL supremacy for sure. Your keyboard sounds watery. Yeah, it's very... I like kind of like a slippy keyboard. I don't like a poppy mechanical one, admittedly. Ah! Dude. It's no one's fault, by the way. It's just it's programming. I was saying to someone in chat earlier that sometimes program problems take, X amount of time, and the only thing I have control over is how much time I spend on the problem, not if it gets solved or not. So I just have to keep putting in time, and then that's it, and not worry about the outcome. Still, though, I can be a bit... So I'm going to get rid of this translation. I'm just kind of curious now. How on earth do you behave to this? I have shared source stuff, so my language doesn't help. I see. Got you. Yeah, okay, so it does at least not degrade the billboards into oblivion, but it doesn't do anything, which I kind of expected because we don't have the rotation. Now, question. Kind of a crazy idea. What happens if I just set up the rotation to be like this? Let's see. How many hours do you program daily? About 4 hours-ish. So... right. Okay, so it is rotating. Okay, right. I'm back. From almost killing yourself. I hope you mean in Minecraft. It'll get fixed when the new DXC versions come out. I see for slang. I'm probably gonna get cooked in. I'm probably getting cooked in the Twitch chat. Oh, you wouldn't want to believe what they're saying about you in the Twitch chat. No, I don't know. We're just trying to figure out this type of thing at the moment. Hey, at least I don't go on a rant about being a positive like an LLM. Sure. Yeah, I guess. Man, I just need a break for a minute. Oh, stretch time. Oh, I'm gonna go back to what I was doing. I think this is fine. I hope that's okay for you guys. I know it's maybe perhaps a little bit frustrating to watch me go in circles a little bit. So what I'm going to do, I'm going to ignore the rotating by... What I want to do is just get the right and get these vectors, yes. Also, I hate GLSL 2. AI generate my shaders. Well, that's probably why you hate GLSL. I'm so good I don't even know what you were doing in... What you're going in circles on. I'm going in circles because I keep trying to transform the data by values that just don't work at all. So what I mean is, like, I'm trying to get these always to face the camera. They always are facing the camera in one way, but they're not facing... The emitter is not facing the camera. So when I do this, for example, this is not following my camera. It's just kind of going off in one direction. And the problem is when I try to rotate it by other things, then it breaks the billboards. These are billboards. These are just like 2D textures that are faking 3D, right? I see. There we go. Yeah, I can't imagine debugging vibe-coded shaders, but I'm sure people enjoy it, I guess, because that does happen. I'd rather die in Minecraft Java Edition. Yeah, I would say I'm strongly against that myself as well. Anyway, so let's... let me think. Oh, this is so confusing. Yeah. Oh yeah, people don't enjoy. I see. That's good. That's good. I'm glad people aren't enjoying vibe coding. It sounds expensive and boring, to be honest, to me. I'm not gonna lie. I guess it doesn't really matter now. Okay, so yeah, I'm gonna get the up and I'm just gonna get it straight from the matrix, from the camera view matrix, because that's what I want to rotate it by. So we're in camera space here. We're rotating it by we've got particle and particle space, and I'm trying to rotate it into camera space from object space, I guess, but it'll be particle space. I enjoy debugging with I enjoy debugging AI written code. So it's like enjoying debugging AI written code. It's like eating food somebody else chewed for you. I like that. That's so funny. That's legit funny. That that's actually quite good. You see, I just never done it. Anyway. Yeah, they're in world. Are they in world space? That's a good point, actually. They could. Are they in world space? If I multiply, because I would need to get them out of particles, out of their local space into world space, and then multiply them in camera space, for anything to even work. Let me sort out the music real quick. I think we've had enough of that. Let's stick on. Yeah, Fisher's Horizon, that'll do. Yeah, let me I don't know if my, sorry, I had to sort something out then. Oh, this is so confusing. It's because it goes to... The reason it's confusing is because the particles go through two different like transformations. It's not like a regular model, right? And what I'm confused with is, okay, so we do some transformation here, some arbitrary transformation based on something, right? I don't know what space we're in actually here. If we're just multiplying by some arbitrary vector, I would guess we're in world space. But then we go into this shader here, and we take our positional data that we worked out, we add the vertices to them, and we multiply by the world and camera up and right. That gives us that projects everything onto the XY plane of the camera, right? This then gets in here. That's the vertices themselves. So that gives us the vertices, and then we multiply it by the view projection matrix, right? And the transform of where they emitted from. So this would be like the transform. That'd be the model coordinates. So that would be the what is it called? Particle emitter / set space, right? So view projection. That'll make the view projection matrix. That's multiplied by the model space, which in this case would be a particle emitter, and then we multiply by the transformed world. The only thing that this is actually doing here, this is the only thing it's doing, is changing where the particles live, right? Sorry, start from. This is all it's doing. It's just, if I get rid of this completely, like nothing, it doesn't break. It won't render. It'll be hard to see. Oh, I didn't save, did I? Whoops. Okay. Let's close that. So if I get rid of that, right, give this a run. Start. See, it just stays there. That's all it does. It's not that interesting. All the particles are in one place. The origin of where their particles live is there. The only thing that's causing the particles to emit, from a different direction is the fact that we have a transform built into them. It's that thing. That's actually changing the position of the individual thingies. What I need to be is this guy, I think, needs to always be... that also needs to be projected onto the XY plane, I guess. Good luck with your coding, dude. So, yeah. No, Garib is... Bed, thank you for joining us, has said in the YouTube chat, hey, Escape, do you have a data-oriented ECS in your engine, or are you using object-oriented approach? No, he's talking about his thing, 214. No, I don't have a data-oriented ECS, but I have data-oriented and non-ECS stuff. I am going a data-oriented approach though, to take things. Yeah, I'm with you on that 214. Yeah, I know. Yeah, don't worry, I remember you guys. Anyway, so I missed something that Tonks said. I was talking to an industry people, and they said increasing use of AI for code reviews and summaries, but still holding on generated code. Okay, so are we in world space or not? That's the question. I don't know. I think I'm going to say yes, because there's no indication. Yeah, if we multiply by... Yeah, okay. What I'm going to do then is I'm going to take this map 4 and do exactly the same shit and assume that our particles have and up and like these guys are here, right? And I'm just going to see how these behave when we use them here. Up. I don't think we ever did this combo. Yeah, so I'm gonna keep that there. That's fine. Next, I want to send up my. All right, I'm saying ugh because I've got to like change this again for the probably 6th time. Let's say view for ease. Again, this is mostly demo code. What is this called? Yeah, view. Okay, and take this and put this here. And we're just going to see how that behaves. If it doesn't work, we'll try another thing. We will eventually get through this, even if it takes me 10 billion years. Well, I'll be dead by then, but who knows. Alright. I think that's not going to crash the GPU. Scene2D does know what that is. Oh, yeah. Alright, so if I take this, there we go. Build particles 93. All right. Yeah, I'm gonna get rid of this and reading other people's code is worse thing, so I don't know why I'd use an LLM. So that makes sense, yeah. 3. Get rid of this. Yeah, just bear with me, gang. Sorry, I'm not quite sure what you're talking about in Minecraft. The ratchet. Oh, yeah, dying 10,000 years. Yeah, don't worry, I'll live forever for you guys. I can't not stream every day. You know. So in 10,000 years, I'll be alive. It's the only thing that's going to keep me going. Boo. It's almost right. It's just facing the wrong way. Do you know what I mean? Yeah, I think what I need to do actually is just make sure that the right vector is correct, because that's almost correct. It's always facing one direction, I think. Let's just look at that again. I might just be copium. This might just be pure copium. Yeah, CFOs and Vulkan game dev working on quantum path tracing. Exactly. Alright, so it's always facing up, and if I look it up, Is it fighting to face up? No matter what I do? I don't think it's done anything at all. But I can't... I think it's copium. Pure copium. That this is even remotely correct. I don't know what to do. I don't want to study either. I'm thinking about like, okay, if I don't know what to do, I need to like figure out how to do this, right? You know, if I was to reverse this, I just think it's just going to look down the whole time instead. That is my starship, yes. That doesn't do anything at all. So I think this right vector thing is just not doing anything. Oh, I'm an idiot. I'm using the wrong thing. What does negative forward do then? I mean, we could send in that, but I think we've already done that, right? Yeah, it just points down. And if I reverse the rest of the directions, I don't think it's going to get anywhere. I mean, we could just multiply by... let me think. I know that's not correct, but... what does that do? Yeah, it's just component-wise operation. It's not, doesn't make any sense. I'm just going to reverse the directions again. I don't know if that works. Does that work? Does it know what to do with that? Nothing? Okay. I could just make it like a supernova when you fly around. Yeah. What do I need to study to know this type of stuff in the future? Because that's the next question. It's like, okay, I don't know how to do this. Now I'm not the best at math, but what if I am? I feel like I need to study a bunch of maths, right? So you'd figure out the way the particles need to be emitted and emitted in that direction. Oh. Oh, I can't type in chat. Okay. I can't type in the Twitch chat. Never mind. Why can't I do that? Like that? Okay, yeah, I can. Um. Yeah, I think that's right. I think my space, yeah. I just don't know the space. The spaces is what's tripping me up in a space game. There we go. I need... What do I need to do? Yeah, so what I'm going to do actually is... So, yeah, emit the particles from that direction. I don't know what direction, that's the problem. Like, if I have a... Yeah, I know what you mean, like, right, if we can figure out the answer, then we can, like, work backwards and do the algebra, right? Like, it's like, if we had, like, you know, if I knew the answer is x equals x, c plus whatever, 5, then we can just be like, alright, yeah. We can do the algebra to work out that, you know, c is equal to 5, right? So then we can construct the direction that we need. But what? Hang on. Maybe we do. Maybe we do. Actually, I'm lying. No, I think you're right. Actually, that's the kettle. Yeah, I'm right next to the kitchen, or in the kitchen, really. I stream from the kitchen. My setup is incredibly scuffed. My keyboard is on my lap. Yeah, I think you're right. I think we know for sure that when the camera direction... Okay, let's just get rid of this velocity thing for a minute. We know one solution, which is... Whoops, what the hell? What is happening? What? Okay. Right, if we get rid of this, and we say that velocity 3 is equal to... Or vel is equal to vec 3 0.f 1.f, I think 0.f, right? No, there it is. It's the negative z direction, right? And if I run that, my kitchen bar stool carried me through COVID, remote working. Yeah, any kettle griefed me in the process. Yeah. At least you can relate. I think you always want that to be... Yeah, because it's all... Yeah, I think you're right. Right, so that's always facing the camera. And if I was to put this into render doc and look at the rotation, the translation. The view matrix is an identity matrix with the translation changing, and the rest is just the projection matrix. Multiplied them together. But as soon as I rotate this way, then I need it to... That's what I always need it to be. So it's not -1 for us, because I've got reverse Z, if that's what you're wondering why that's correct. Sir Trunks. Yeah, reverse Z perspective. Yeah, exactly. if I haven't moved the camera, then it just has translation. It's the identity matrix. So when I start the game, I've seen this in the when I do this, for example. No, I haven't rotated the camera yet. It's just translation, and that's what it needs to be at translation. It needs to be this. In fact, I'm going to get rid of something real quick in the game code. So we know with when we have an identity matrix, the velocity needs to be -1. Sorry, 1. Just 0, 0, 1. Do we still have the view matrix in here? So if I take the right matrix, what does that look like? It's a vec3, yeah. You can translate 001 to world space with the view matrix. Yeah, that's what I'm trying to do. What? Oh, okay, so this is not the same. This is not what I thought. What? Interesting. Let me just negative that. Just make sure it's not doing the opposite direction, if you know what I mean. That was confusing. Because if it's perfectly going in the other direction, then we'll see... You scare me when you say what. No, okay. Why is this facing... What way is this facing? So confused by this. Maybe that's not my right matrix. Okay, so I'm kind of copying the names here. That might not be right at all. This might be correct. Yeah, I'm just going to try like a couple of different ways. I know this says up, but I'm just trying to get the camera to literally face the same direction based on what we just did. Nope. So I believe this, I think that's, okay. Let's go back. Now if I negative this, maybe that's the right vector. Please. Why when I spin this way around is it firing that way? It's like I'm being disobeyed by my own, you know what I mean? Like, I'm like, alright, yeah, I'll look at that. Wait, why are you over there? Alright, I'll rotate that. Okay, why are you over there now? What are you doing? You know what I mean? You go upside down, right? Let's see. So this is upside down. What? Okay, so yeah. Okay, we've got the other option here. We can get the forward vector. Which is very clearly just this. Is that correct? No. Sorry, got that slightly wrong. There we go. And then this, right? So we just want to see this vector face the way of 001 with no rotation involved. What? Nope. You don't change at all. And obviously negative then, obviously, I assume you're always 0, 0, 0. Yeah, okay, that is correct. But I assume this is just a 0, you know, and nothing. Yeah, okay. Okay, cool. Did I change that thing that I wanted to do? I don't think I did. Let me think. So I'm currently scaling this by... No, not this one, but the other one. I'm scaling my directional vector by 2. I just want to change this to 1. Or just not do it at all, to be honest. Yep, there we go. Okay, so... I just want to make sure this is 100%, like, not being scaled by something and the magnitude is too long or something. Interesting. That made it disappear. But that's fine because we use these things that weren't very good. Anyway, and again, we should be... So maybe that was messing us up, right? Maybe we're translating things by something that wasn't 0, 0. Do you know what I mean? No. Now nothing's rendering. Oh no, it's staying still? Okay. Right, I'm going to have to head to the loo real quick. I'll be right back. Okay, I'm back. Oh, would you look at that? Alright. Alright, so what I'm going to do is... I think what I need to do is I need to study some spaces, right? And figure out like how to get the how to work out with these spaces. Should have paused that. So I think I'm going to do that. First things first, though, I'm going to share my well, I'm going to share my Discord server with anyone in the let me just grab out my Discord link that will last for 30 days. I know it's in the description, but I'll post it here anyway. Oh, I can't. I can't post it on my laptop because my laptop is signed out. So I'm just going to have to go disable streamer mode, which I don't really see the point of. And grab this, copy, go into the Twitch chat, press paste. There we go. There's a convenient link for you guys. While I'm here in the YouTube chat-a-rooney, I'm going to paste that there. I am going to end it here, guys. I hope you've had a good stream. Thank you for joining us. Thank you for joining us in the first time. If you have on Twitch, I know that's kind of a new experience for me anyway. So yeah, hey, we're just about to end, unfortunately. Bye-bye, friend. Bye-bye to you too, man. Let's bring up the YouTube chat because I kind of lost you there. I was there. You were there indeed. We'll get there all the time. Thank you for turning up for this lovely situation. Appreciate you all. Thank you for all the follows on the Twitch if you did follow me. I know I saw some couple of ones. Thank you for all the likes, comments, and subscriptions on YouTube. It's always very much appreciated. And thank you for staying subscribed, honestly, and staying followed, I guess I should say too. It's always appreciated. I liked your stream. Thank you very much. That's very much appreciated. Yeah, so good luck with your coding and whatever you end up doing for the rest of the day, guys. And I'll see you all shortly. Yeah. And I'll try my best to get these spaces understood, right? Okay. In the meantime. All right, bye, guys. I assume when I press this, we'll see you later. All right. Bye-bye.